For thousands of years, people knew only about the planets Mercury, Venus, Mars, Jupiter, and Saturn, which they could see using simple telescopes, or even by the naked eye if conditions were good. But in the late 18th century, a famous astronomer named Sir William Herschel discovered a new planet that was icy blue in color. At first, people thought it was a star, but later they realized it was a planet. Today, we know it as Uranus, a planet that's more than 19 times farther away from the Sun than Earth. It's so far away that it takes Uranus 84 years to complete one trip around the Sun. This astronomer also discovered many other interesting things in space, like double stars and nebulae. In the mid-1800s, scientists noticed something pulled Uranus and strangely tugged its orbit. They thought there must be another planet out there, and they used math to predict where it would be. Finally, in 1846, they found Neptune using a telescope. It was too faint to see with the naked eye because it was too far away from the Sun. It was all so exciting. Who knows how many other planets could be there, lurking in the darkness of our solar system? Back in the mid-1800s, astronomers noticed something unusual was happening in the sky. A small rocky planet named Mercury was behaving strangely. It didn't follow the predictable orbit that was expected of it. One of the astronomers was a brilliant French scientist named Urbain Le Verrier. He came up with a theory that there could be another planet in our solar system no one had yet discovered. It would be located somewhere between Mercury and the Sun. This hypothetical planet, which he named Vulcan after the Roman god of fire, would have an incredibly hot surface, and it could be a potential explanation for Mercury's strange behavior. He never surely claimed Vulcan was really the one thing disturbing the orbit of Mercury. But, excited by the possibility of discovering a new planet, astronomers all over the world took the idea of Vulcan. For a planet that didn't exist, people committed to developing ideas and getting information about it. Some scientists didn't think it was likely that they had missed another planet as big as Mercury. It would have been hard not to see it by then. But there was a tiny chance of a smaller planet existing inside Mercury's orbit that was too close to the Sun, so no one could see it. One theory said it was about 13 million miles away from the Sun. Mercury is the planet with the most eccentric orbit in our solar system, but the closest point it gets to the Sun is about 28.5 million miles. This means Vulcan would be under half of that distance. The theory moved on, saying that if Vulcan existed, it would orbit the Sun every 19 days and 18 hours, and its path would be tilted about 12 degrees relative to the path of other planets in our solar system. Vulcan's position at its furthest point from the Sun would still be too close to the Sun to be seen with the naked eye, even during twilight. The only chance of seeing Vulcan would be during a solar eclipse, or when it passed in front of the Sun, which, as the theory said, would be 2 to 4 times a year. They had a theory that this mysterious planet was so close to the Sun that it could only be seen during a total solar eclipse when the Moon blocked out the Sun's blinding glare. So, every time there was an eclipse, scientists would peer at the Sun, hoping to catch a glimpse of Vulcan. They were trying really hard, but no matter what, they couldn't find this mysterious planet. Some astronomers claimed to have spotted it during eclipses, but no one could ever confirm or find evidence for that. The theory of Vulcan was left waiting for some better times. Einstein had a different idea. You know about his theory of general relativity, right? That's where he claimed gravity wasn't some sort of natural force, but a result of space-time curved because of the presence of giant space objects, like planets and stars. Planets circle around the Sun in their usual orbit because space-time is curved. That means the planets are kind of falling towards the central star of our solar system. And Einstein tried to explain Mercury's unusual orbit using his own theory of relativity. Unlike the other planets in our solar system, Mercury's orbit wasn't that circular. Instead, it seemed to wobble slightly, as if there was an invisible force pulling it away. Einstein said this could be happening because the massive gravity of our sun was actually curving the fabric of space-time around it. He claimed it's possible this changed Mercury's orbit a little bit. It took the scientific community a while to test this theory, but it eventually seemed like the most plausible explanation. Even though Einstein's theory gave us a more elegant explanation for Mercury's strange orbit, some scientists were still holding out hope for Vulcan. It was especially hard to let go of the idea of Vulcan because Mercury is also the planet that's really hard to see from where we're standing. But later, more and more scientists started accepting Einstein's theory above their imagination. And they would observe a total solar eclipse specifically to test Einstein's theory of relativity, not because of Vulcan. And Vulcan is not the only hypothetical planet everyone was talking about. In the newer age, some believe there could be a mysterious planet lurking in the outer part of our solar system. But this one is more likely to exist. No one has seen it directly yet, but computer simulations show this so-called Planet 9, or Planet X, is probably somewhere there beyond Neptune. Neptune and Planet X could be similar in size. Planet X could be 10 times more massive than Earth and circles around our Sun in an elongated shape, which is on average 20 times farther from the Sun than Neptune. A year there may last between 10,000 to 20,000 Earth years. By comparison, a year on Neptune lasts 165 Earth years. Something this big moving out there beyond Neptune could explain the unusual orbits of smaller objects in the Kuiper Belt. The Kuiper Belt is the area of our solar system beyond Neptune and where it orbits. And there are most likely many asteroids, comets, and some other smaller bodies there, mostly made of ice. There was another hypothetical planet called Nibiru. Remember those rumors that the world could end back in 2012? One of the popular scenarios was Nibiru, which some claimed would hit our home planet at the end of the year. Of course, nothing happened. We're still here, all set and good, but the idea of Nibiru seemed interesting. Stories started in the 1970s when a man named Zecharia Sitchin mentioned Nibiru in his book, The 12th Planet, claiming it orbits the Sun every 3,600 years. But there's no chance a planet with such an eccentric orbit wouldn't disrupt other planets in our solar system with its gravity. And if it was really coming that close to Earth in 2012, we were supposed to be able to see it with the naked eye. Some simple calculations showed Nibiru would have been nearly as bright as Mars at its dimmest and brighter than the faintest stars you see from a city. Oh well, maybe we'll have more luck in the next 3,500 and something years. In 2011, a comet named Elenin appeared that many people thought could be Nibiru. But when you're looking at comets and planets through a telescope, you see they appear differently. A comet has a coma, which is a gas atmosphere, together with a tail, something a planet doesn't have. Plus, this comet didn't slam into the Earth. It came too close to our Sun and fell apart. The leftover pieces will continue moving on their way to the outer solar system for the next 12,000 years.
So, we might be getting closer to finding a massive icy planet beyond Neptune's orbit. Yeah, sorry Pluto, still not you. Recently, some universe mapping using data from a telescope in Hawaii eliminated about 78% of the possible locations for this mysterious Waldo from space. Some people call it Planet 9, while others prefer Planet X. Either way, it's been causing controversy since its existence was first proposed, and that is mainly because no study so far can answer the big question: does it really exist? If discovered, Planet 9 would rank as the fifth largest planet in our solar system, with a mass 10 times that of Earth. It's also theorized to be gaseous, like Uranus. The initial study on Planet 9, dating back to 2016, suggests that this colossal new planet orbits the Sun 29 times farther out than Neptune, which sits at about 2.8 billion miles. As a result, the Planet 9 would take between 10,000 and 20,000 years to complete a single orbit around the Sun. If confirmed, This yet-to-be-understood world would dominate a region larger than any other known planet in our cosmic neighborhood. These are all intriguing hypotheses, but without a single piece of evidence or observation to back them up. Before dismissing this as a wild guess, it is important to note that these researchers relied on complex mathematical modeling and computer simulations to speculate about the planet's characteristics, because that's what they do. The hypothetical presence of this planet would explain various mysterious features located beyond Neptune. We are specifically talking about the Kuiper Belt, a huge donut-shaped region filled with icy debris left over from the formation of the solar system, including comets and dwarf planets like Pluto. What happens is that the 6 farthest objects in the Kuiper Belt exhibit elliptical orbits that are all oriented in a similar direction within physical space and tilted approximately 30 degrees downward relative to the orbital plane of our 8 known planets. What's strange here is that, despite their distinct orbital velocities around the solar system, they maintain this alignment. The likelihood of such alignment occurring randomly is extremely low, around 0.007%. So, here comes Planet 9, a hypothetical massive celestial body that offers a plausible explanation for this strange phenomenon, potentially exerting gravitational influence to shape these orbits. The initial theory didn't hold up for long, facing accusations of observational bias and calculation errors. Then, in 2017, another study popped up, sparking back the idea that maybe Planet 9 is out there after all. This time, Spanish astronomers tried a novel approach, focusing on observing extreme trans-Neptunian objects. These celestial bodies orbit the Sun in highly stretched elliptical paths, with average distances exceeding 13 billion miles. The research suggests that the distances between these objects' nodes and the Sun might provide clues to Planet 9's location. You see, these nodes are the points where a celestial body's orbit intersects the solar system's plane. When these objects reach these points, they're more likely to interact with other solar system bodies, potentially causing significant changes in their orbits or even collisions. So, if the trajectory of these extreme trans-Neptunian objects remains stable, everything's fine. But if it's not, well, that's a sign that something else, something big, is messing with their path. And that's exactly what the research found. There is something unseen out there, throwing these objects off course. And that something could be a planet, chilling at a distance between 300 to 400 times farther from the Sun than Earth. To this day, the study of the extreme trans-Neptunian objects is the strongest evidence we've got for Planet 9's existence. And if you're still not convinced by this theory, know that strange motions like these have led to planetary discoveries before. Neptune, for instance, was spotted because Uranus's motion didn't quite agree with the predictions of Newtonian gravity. But the deflection of its orbit could be explained if it was caused by a pull of an undiscovered planet. And just like that, we discovered Neptune. Now, the year is 2021, and there's all this buzz about Planet 9 again. After correcting some old guesses, studies are now leaning towards the idea that this mystery world follows an epic loop around the Sun every 7,000 years. That is massive news, because it means this planet might be closer than we ever thought, making it easier for our telescopes to spot it. The paper also suggests there is a whopping 99% chance that the funky orbits of these distant objects are all because of this unseen planet, not just some cosmic coincidence. Now, the odds of this whole situation being a fluke are down to a 1 in 250 chance, which is much better than the 1 in 10,000 chance back in 2016. All these optimistic numbers have brought us to where we are today, keeping our hopes and working on better equipment to continue the mission of spotting Planet 9. As mentioned earlier, researchers in Hawaii created some kind of treasure map utilizing the Panoramic Survey Telescope and Rapid Response System to eliminate 78% of its locations. This is great news, considering how challenging it is to find a planet-sized needle in a cosmic haystack. But unfortunately, Planet 9's presence remains a ghost in the dark outer reaches of our solar system. Enthusiasts are still convinced of its existence and believe it is only a matter of time before we celebrate the discovery of Earth's new cosmic cousin. They're putting their hopes on the Vera C. Rubin Observatory, which is currently under construction in Chile and is scheduled to begin science operations in late 2025. Over the course of 10 years, this observatory will scan the entire southern hemisphere sky every few nights with a 27-foot, fast-moving telescope equipped with the largest digital camera in the world. The idea is to catalog everything in the solar system, reaching out to and beyond Neptune, and tracking the movements of millions of celestial objects, including space junk, asteroids, comets, and stars. If Planet 9 is indeed out there, this next-generation telescope could be the one to find it. The existence of this mysterious planet is far from being universally accepted in the scientific community. That is simply because Planet 9 isn't the only explanation for the strange phenomenon occurring beyond Neptune. One theory suggests that a group of distant objects, such as dwarf planets, comets, and moons, might be collectively influencing the orbits of the extreme trans-Neptunian objects. Others believe that a black hole is behind all this. These compressed masses are some of the densest objects in the universe, potentially capable of affecting the orbits of other masses, like how this supposed ghost Planet 9 is believed to be doing. Another bold perspective suggests that our current understanding of the laws of gravity is flawed, actually incomplete. This theory, known as modified Newtonian dynamics, proposes that these distant icy objects exhibit strange behavior not due to influence from another planet, but rather because the immense gravitational field of the Milky Way is influencing them. However, even supporters of this theory acknowledge that it is too early to draw firm conclusions, and much more extensive research is still required. While we continue our relentless hunt for Planet 9, some astronomers have taken it a step further, suggesting the existence of a hypothetical Planet 10. This world has a mass and size like that of Mars or Earth and is located on the edges of the Kuiper Belt. But the thing is, if this alleged Planet 10 is indeed as small as scientists believe, it might not have enough gravity to clear its orbit of debris. And that is pretty similar to what happens with Pluto, being one of the reasons why it got into trouble back in 2006. So yeah, it's better not to get too excited. This supposed Planet 10 might end up classified as another dwarf planet.
Look at this fascinating planet. It looks as if it's burning. It must be hotter on its surface than in the middle of Death Valley. The ground is parched, cut by giant cracks. There's not a drop of water in this boiling world. Now, it's the same planet, but it looks like a totally different place. Everything is frozen. The temperatures are so low, there isn't even a tiniest chance that life could survive on this planet. This bizarre world is called HD 20794d, and it's located 19.7 light-years away from Earth, in the constellation Eridanus. This planet is a super-Earth. This term means that it is larger than Earth but smaller than such ice giants as Neptune. What makes this planet especially interesting is its unusual orbit, which moves it in and out of its star's habitable zone, the region where temperatures might allow liquid water to exist. Now, we haven't seen this unusual planet directly. Astronomers detected it by measuring tiny wobbles in its star using two powerful instruments, espresso and HARPS, located at telescopes in Chile. These instruments measure radial velocity, which is the small movement a star makes as a planet's gravity tugs on it. The larger the wobble, the more massive the planet. Later, astronomers analyzed the data and figured out that the planet in question has a mass around 6 times greater than Earth's. It orbits a star, which is slightly smaller and dimmer than our Sun. What makes this star unique is that it is bright enough to be seen with the unaided eye, unlike many other stars that host exoplanets. You won't be able to see them without a telescope. The star system has been observed for over 20 years. Astronomers have long suspected it had multiple planets. In 2011, scientists discovered two other super-Earths orbiting the star every 18.3 and 89.6 days, respectively. For some time, researchers thought they had found a third planet with an orbital period of 40 days. Later, they realized they had made a mistake. But recently, after reanalyzing years of data, astronomers have confirmed that the third planet does exist, and it's our extreme HD 20794d. A researcher from the University of Oxford played a key role in identifying the planet. He used a special computer algorithm called Yarara to separate the planet's weak signal from the background noise. It helped him confirm that the planet truly existed and was pretty unique. Unlike the planets in our solar system, which have mostly circular orbits, the newly discovered one follows a highly elliptical, stretched-out orbit. It takes 647 days to complete one trip around its star. That's just 40 days shorter than Mars's orbit around the Sun. At its furthest point, the planet is twice the Earth-Sun distance, which makes it an icy world far outside the habitable zone. At its closest point, it moves inward to 0.75 AU, where it enters the habitable zone, where liquid water might exist. This extreme movement creates truly bizarre seasons. For some part of its orbit, HD 20794d is frozen, like an icy wasteland. As it approaches its star, temperatures rise and ice likely melts, forming temporary oceans. The planet then experiences a short, scorching summer. It is so hot that the water on its surface might evaporate into the atmosphere. Shortly after, the planet moves away again. It triggers a gloomy fall with rains, followed by a deep freeze in winter. In other words, the planet switches between extreme cold and intense heat, which makes it a very unpredictable place for life. If any life forms exist there, they certainly need to adapt to dramatic changes in temperature and environment. Why does the planet follow such a mind-boggling orbit? It might be a leftover effect from events billions of years ago, when the planetary system was still forming. At some point, another large planet may have disturbed the orbit of our extraordinary friend. Another possible explanation is that a giant planet once existed in the system, and its gravity pushed HD 20794d into an elongated path. Later, this giant planet may have been ejected from the system, leaving the smaller planet in its current orbit. This theory makes sense because the two other planets in the system, B and C, have more normal circular orbits. The discovery of this planet is so exciting because it challenges what we know about habitable planets. Most planets in the habitable zone stay there permanently, but HD 20794d only passes through it. Scientists want to know if such a planet could still support life, even briefly. So future telescopes will study the atmosphere of this planet, looking for signs of water, gases, or even life. Another super-Earth that might have the right conditions for life orbits a star 137 light-years away. In space terms, this is considered relatively close. A light-year is around 6 trillion miles. The planet is called TOI 715b, and it's about 1.5 times the size of Earth. Unlike HD 20794d, it's permanently located in the habitable zone. Look, that's what astronomers think the planet might look like. TOI 715b orbits its star very quickly, completing a full orbit in just 19 days. But even though it's close to its star, it may not be extremely hot, all because its star is a red dwarf. That's a type of star that is smaller and cooler than our Sun. This means TOI 715b could have a milder temperature compared to other exoplanets that orbit closer to hotter stars. NASA discovered the planet using the Transiting Exoplanet Survey satellite. This space telescope finds planets by watching for small dips in a star's brightness, which happen when a planet passes in front of it. Since red dwarfs are smaller and dimmer than the Sun, planets passing in front of them are easier to detect. Astronomers are planning to study the planet further using the James Webb Space Telescope. This powerful telescope, located 1 million miles away from Earth, can analyze the atmospheres of distant planets. If TOI 715b has an atmosphere, JWST could help scientists determine what gases are present in it and whether such conditions could support liquid water or even life. One more promising world for our search for extraterrestrial life is an extremely dense super-Earth in the K2360 system. An international team of researchers from Japan and Europe has discovered this remarkable multi-planet system orbiting a Sun-like star located 750 light-years away. This system has 2 planets, including one of the densest rocky planets ever found. The K2360b is a rocky super-Earth, about 1.6 times the size of Earth, but with a mass 7.7 times greater. This makes it as dense as lead. The planet orbits its star incredibly fast, completing one full orbit in just 21 hours. It's the densest known ultra-short period planet with well-measured properties. As for its sibling, this is a much larger outer planet with at least 15 Earth masses. It takes 9.8 days to orbit its star. Sadly, since it does not pass in front of its star from our viewpoint, scientists cannot determine its exact size. The unusually dense planet might be the core of a much larger planet. Over time, intense radiation from its parent star may have blown away its outer layers, leaving behind only its dense, rocky core. So, in fact, this planet could show us what might happen to some planets that are too close to their stars. Astronomers think that the planet may have moved inward over time due to interactions with its larger companion planet. One possibility is high eccentricity migration, where a planet's orbit becomes highly stretched out due to gravitational interactions before gradually becoming more circular near the star. Another theory is that the planet's spin and axial tilt can cause its orbit to become more circular. Such planets are rare, and finding one with a massive outer companion can help scientists refine their theories about how planets form and evolve in extreme environments. With its help, we might also understand how rocky planets evolve and what happens to planets that get too close to their stars. Right now, 4 tiny, Earth-like planets are chilling around one of the closest star systems to us. We're talking second closest. These little rocky worlds are each about 20 to 30% the mass of Earth. So not quite Earth 2.0, but still pretty solid. Will one of them become our new home one day? Well, all of them are pretty close, so future humans might actually visit them someday. Not like next year or anything, but we could potentially send missions there. Don't expect any extraterrestrial neighbors, though. Those planets probably aren't home to life, or at least not anything we'd recognize. Let's take a look at them. The planets are called Barnard B, C, D, and E. How creative, huh? The innermost has a mass of 26% of Earth. The second one is a bit bigger, with a mass of 30% of Earth. The third one has 4% more mass than the previous. And the outermost is... no, it's not the biggest. Actually, it's just a baby, with a mass of 19% of Earth. All the planets are likely rocky, like the inner planets of our solar system. They orbit their star very closely. That's why they only need a few days, under a week, to make a full circle. Now, what about that star these little guys are circling? It's called Barnard star. Astronomers have always had a hunch there might be at least one planet orbiting it. First off, this star is super close, in cosmic terms of course. Only the Alpha Centauri trio is closer to us. Barnard star is just under 6 light-years away, which is basically next door. At the same time, it's not like our Sun. Barnard's star is a red dwarf, the most common kind of star out there. It's got only about 1/6 the mass of the Sun. But red dwarfs are a goldmine for learning about planets outside our solar system. And studying Barnard's star can help scientists figure out what planets around single stars, like our Sun or this red dwarf, are like. Or what kind of environments red dwarf planets might have. And most importantly, we might finally find the answer to this super important question. Could any of these places actually support life? For the longest time, scientists thought there might be a big Jupiter-like gas giant hanging out near Barnard's star. All because the star has a little wobble. It looks as if it shifts towards and away from Earth over time, so something might be tugging on it. Interestingly, it wasn't a giant planet doing the pulling. According to a study from March 2025, it's actually 4 smaller rocky planets, each about 4 times the mass of Mercury. One day, they ganged up and started tugging on the star together. These planets are incredibly close to their star, so close that they can whip around it in just a few days. Sadly, because of that, they might be way too hot for anything like life. Besides, since these 4 seem to explain all the star's movement, the researchers think there's probably nothing else orbiting the habitable zone. So, there's no Earth 2.0 orbiting around Barnard's star. Still, it's an awesome find, especially since this star is basically our cosmic neighbor. Plus, the system might not stay off limits forever. With nuclear fusion engines or light sails, futuristic propulsion systems that could make the trip way faster. We might probably go there one day. And then we'll finally figure out if these worlds are really lifeless and maybe even colonize them. Now, let's see how scientists found the star's hidden planets. Normally, astronomers spot exoplanets when they catch them crossing in front of their stars and blocking some light. But Barnard's star is tricky because, in our view, it's like we're looking from above the system, so its planets don't block the light in the usual way. That's why they call it the Great White Whale of planet hunting. To get around this, researchers used a super-sensitive instrument called Maroon X attached to the Gemini North telescope on Hawaii's Mauna Kea volcano. Over 112 nights, spread out across 3 years, the telescope picked up tiny changes in the star's movement. These shifts let scientists figure out how many planets must be tugging on the star, as well as estimate their sizes. At first, they found 3 planets. But then they used another device, deliciously called Espresso, and located at the Very Large Telescope in Chile. And only after a shot of this espresso did they find a 4th planet. By combining the data from both instruments, they were able to more or less confidently say their findings were solid, not just random glitches in the data. Even though red dwarfs, like Barnard's star, are the most common type of star in the universe, most are way too far for us to see planets around them easily. These new findings suggest that small rocky planets could be pretty common around these stars, and that's huge for future discoveries. Now, finding new exoplanets is cool and all, but it might be even more exciting to dwell on their birth and evolution. And a recent study has made the sweetest discovery ever. Newly born exoplanets might actually look like Smarties, that popular British candy, rather than spheres. We've always kinda assumed that baby planets are born ball-shaped, but they might be oblate spheroids instead. A team of scientists from the University of Central Lancashire in England used computer simulations to build a model of the formation of planets in dense gas disks surrounding young stars. After that, they compared these models with actual observations and noticed that the young planets took pretty unusual shapes. The thing is that even though almost 6,000 exoplanets have been discovered so far, astronomers still don't have a clear understanding of the sequence of events marking their birth and early evolution. But this new research might finally shed light on this process. So, the astronomers examined the formation mechanisms of gas giant planets like Jupiter and came to the conclusion that planets built up from their centers. After that, the researchers focused on the initial shapes of such planets. They were also interested in how they could encourage the growth of these planetary seeds. How could they turn into such massive planets, some of them bigger than our solar system's largest giants? According to the standard theory of the formation of planets, such growth happens gradually and smoothly. First, dust particles start to stick together, turning into larger and larger objects. This process lasts for a very long time and is known as core accretion. It's the model of planet formation scientists favor. There's another theory, according to which planets' birth might happen over shorter periods of time. This data involves a protoplanetary disk, a disk of gas which makes up 99% of its mass, and dust, around 1%. This disk orbits a newly formed star, and hypothetically, planets might form from this cloud. Protoplanetary disks are likely to be common byproducts of star formation. They might range in mass from 0.001 to 0.3 solar masses. Inside such disks, matter slowly moves inward, and dust particles grow bigger, to the size of pebbles. At one point, after 2 to 3 million years, a giant rotating protoplanetary disk breaks into pieces, and that's how baby planets are born. This theory is known as the disk instability model. As for the model built by the team, it seems to support this second, less favored theory: rapid planet formation through disk instability. All because this theory explains how large planets can form relatively quickly at pretty large distances from their host stars. As for the weird flattened shape of these newly formed planets, it might be due to the material falling onto them. Most likely, it goes mainly to the poles of new planets. One of the main conclusions of the research is that the appearance of young exoplanets, as we see them from Earth, may vary depending on how they're angled. If Earth is directed face-on to an exoplanet, it will seem that the latter has a traditional spherical shape. But if seen on edge, a baby exoplanet will look like a real smarty. The team is going to continue to investigate the formation of planets with the help of an improved computer model. They believe they can find out the role the environment around a young planet plays in affecting its shape and formation.
Now, if Earth were the size of a nickel, Neptune would be about as big as a baseball. That's impressive, but it's nothing compared to the giant ninth planet that might be hiding out there. Now, our Planet 9's discovery saga might have finally come to an end. Turns out, the problem wasn't where we were looking, but how. And researchers might have just made the biggest solar system discovery in decades. You see, the idea of finding a planet beyond Neptune has been around for years now. I know, back in school, you probably learned that the ninth planet was Pluto. But forget about Pluto. It's been demoted to a less fancy category since 2006. What I'm talking about is the Planet 9, a hypothetical giant planet that could be our cosmic neighbor. We've never actually seen it, but scientists are pretty sure it's out there somewhere, hiding in the outer solar system. To explain why they think that, we need a sheet of paper. Hey, here's one. We place a coin on it, and suddenly, it starts to move. Unless we're talking about some kind of superpower, there's no way this coin is moving on its own, right? So, you figure someone must be on the other side, holding a magnet and moving it around. You can't see the magnet, but it explains why the coin is moving. That's kind of what's happening with Planet 9. We can't see it, we can't prove it, yet, but its existence could explain the strange movements we see out there in space. For example, the planets in our solar system orbit on a flat plane that's tilted about 6 degrees relative to the Sun. But why 6 degrees? Well, no one really knows for sure. Some scientists think those orbits might be slightly tilted because of the pull of a ninth planet. Its existence could also explain the unusual paths of smaller objects in the distant Kuiper Belt, a region full of icy debris that stretches far beyond Neptune's orbit. Back in 2016, researchers from Caltech published a study about Planet 9. They suggested it could have a mass about 10 times that of Earth and follow a highly elongated path. It's a scientific way of saying it takes forever to make one trip around the Sun. Because of that, it would be located in the outer solar system. I mean, far, far away. It would orbit the Sun about 20 to 30 times farther out than our most distant planet, Neptune. According to scientists, Planet 9 would take up to 20,000 Earth years to complete just one full orbit around the Sun. Since it's crazy far out there, it's almost impossible to see it. So, as cool as this hypothesis sounds, we've never found solid evidence that Planet 9 actually exists. But we might be pretty close. In May 2025, a team at National Tsinghua University might have made one of the most exciting solar system discoveries ever. Alright, so there's a hypothesis that Planet 9 hasn't been discovered yet because we haven't been using the right method. This new study raises an interesting question. What if Planet 9 actually looks brighter in infrared light than it does in visible light? Let me explain. Scientists have been trying to spot Planet 9 by its reflected light. But here's the problem. To spot it in visible wavelengths, sunlight would have to travel all the way out to Planet 9, bounce off its surface, and then travel all the way back to Earth. If a Neptune-sized planet were about 10 times farther away than Neptune, it would look about 10,000 times fainter. But a planet's own thermal radiation, its heat, only has to make a one-way trip. So in infrared light, Planet 9 would only be about 100 times fainter. That's why it makes more sense to look for it using space-based infrared telescopes. And that's the idea behind this new study. The team started digging through archives, searching for old infrared sky survey data, and they pulled it from two main sources. First, IRIS, a satellite launched in the 80s that scanned the sky for almost a year. Then, the Japanese satellite Akari, another infrared observatory that operated between 2006 and 2011. So basically, they compared objects that showed up in IRIS database and noticed which ones had moved by the time Akari took its observations. And by doing that, the researchers found something incredible, an object that might just be our long-lost ninth planet. Because if something moves, it could be a planet orbiting the Sun, right? And yeah, they did find some celestial objects showing tiny movements. But before jumping to conclusions, they had to rule out the parallax effect. And that's something really important when we're talking about solar system discoveries. To explain it, I need you to do something. Hold one finger in front of your face. Close one eye, and now switch. Your finger seems to move a tiny bit, right? That's because you're looking at it from a slightly different angle, from one eyeball to the other. The same thing happens when we look out into space from Earth. Since our planet orbits the Sun, our view of very distant objects shifts just a little. That effect is called parallax. My point is, because of this effect, Planet 9 would appear to move across the sky as Earth goes around the Sun. On any given day, it might seem to be in one spot, but 6 months later, when Earth is on the opposite side of the Sun, it would look like it shifted. 6 months after that, it would seem to move back again. Scientists had to account for parallax. Actually, they had to remove its effects. So the team looked at images of the sky taken on the same date every year. Because on that same date, Earth is always in the same spot in its orbit. That means if Planet 9 is real, it would show up in the same place in those images every year. No fake wiggle from parallax, just its real position. This careful search led them to a single object, a tiny dot in the infrared data. This strange little spot had moved slightly along its orbit around the Sun over the 23 years between Iris and Akari. Wait, could that be it? Did astronomers just confirm a hidden planet? Well, maybe. But don't get too excited. The data we have on its motion over that time is not enough to figure out its full orbit. So, for now, we still can't say for sure if this mysterious object is really Planet 9. It's definitely a strong candidate, though. Based on how bright the object appears, the team estimates it could be pretty massive, and that came as a big surprise. You see, previous NASA research ruled out any Jupiter-sized or Saturn-sized planets hiding out there, but a smaller world would have gone undetected. So the scientists were looking for something just a bit bigger than Earth. But it turns out this mysterious planet might be more massive than Neptune. Now that they've discovered Planet 9, supposedly at least, the plan is to keep tracking it and collecting new data. But don't think the road ahead will be easy. Because since the Akari satellite spotted it for the first time, that object didn't just sit still. It's been moving slowly through space ever since. So now scientists need to use regular telescopes on Earth to look for it again. And here's the tricky part. They're not exactly sure where it moved to, so they have to search a pretty big patch of the sky. And so far, no matching object has been found. Whether this really turns out to be the Planet 9 discovery or not, only time will tell. For now, its existence is still up for debate. But with powerful new technology on the way, like NASA's Nancy Grace Roman Space Telescope, astronomers are more determined than ever to uncover the truth. And if Planet 9 really is out there, hiding in the cold, dark edges of our solar system, it's running out of places to hide.
Take that giant space knife. Yes, you. It's time to visit the sun and check what's inside. First, you're slicing through the corona, aka the sun's wild hair. It's the sun's super thin atmosphere, but don't let it trick you. It's blazing at 3.5 million degrees Fahrenheit. While cutting through it, you see plasma threads whipping around like solar spaghetti. You reach the photosphere, the sun's skin. It's only about 300 miles thick, but it's super bright and sizzling at 10,000 degrees Fahrenheit. Looks like it's covered in little fiery waffles. They're called granules, and they're each about 600 miles wide. Then comes the convective zone, where hot plasma is floating up in bubbly chunks. Next, the radiative zone. This part's like molasses made of light. It takes 170,000 years for energy to crawl through here. Finally, you start cutting into the core, and boom! Instant heat wave. It's like the sun's pressure cooker. Gravity's smashing hydrogen atoms together to make helium, and it's cooking at 27 million degrees Fahrenheit. Now, you're gonna need a smaller knife, since the next candidate, Mercury, is the smallest of the inner planets, only about 3,000 miles wide. When you cut through its thin atmosphere, you see little hydrogen and helium atoms escaping inside tiny invisible balloons popping away into space. Next, the crust. Together with mantle, it's only about 250 miles thick. As our giant knife passes through, you see hard rock flakes falling off, cracking under the pressure. Mercury has a gooey outer metal core. Slice carefully, or you'll spill some liquid metal lava. Finally, you hit the inner core. Mercury has a massive metal heart. Around 85% of the whole planet is just iron and metal. It's basically a giant metal meatball. Cut through it and watch molten iron juice oozing out like spicy hot sauce. You're now approaching Venus, the hottest planet out there. We're talking about average temps of 870 degrees Fahrenheit. Hot enough to melt lead. You slice through the atmosphere and it's crazy. Thick clouds of sulfuric acid swirling everywhere, and it's mostly carbon dioxide. Like a bad greenhouse on steroids. Pressure there is insane, like being 3,000 feet underwater on Earth. Thick yellowish clouds are puffing around the blade, sizzling like acid rain. Then comes the crust. A thin shell of mostly basalt, just 6 to 18 miles thick. It's like cutting through a crispy rock pizza crust, thin but tough. Cut deeper and you're in the molten rock mantle, about 1,800 miles thick. You can see the rocky magma wiggle and ooze. Finally, you hit the metal core, about 1,900 miles wide. That's like slicing a chunk almost the distance from Chicago to LA. There's a giant iron ball inside, all molten and heavy. Alright, time to cut through Earth. Now you might need a whole chainsaw to deal with this rocky planet. First, your chainsaw bites into the crust. It's thin, only about 1% of Earth's volume. You hear a sharp crack as the brittle rocks snap and crumble. Dust and tiny minerals puff out, and the crust breaks into chunks, like snapping a hard cookie. Next, the blade presses deeper into the mantle. Thick, tough rock that's solid but kinda squishy if you wait long enough. As you slice, the hot rock kind of oozes and bubbles, leaving a warm trail along the blade. Keep going, and you hit the outer core, a huge sea of molten metal. Suddenly, the knife slides through thick, glowing liquid iron and nickel, like cutting through a giant cosmic lava lamp. Finally, you smash into the inner core. Solid metal this time, like a glowing steel marble buried deep inside. The blade scrapes across its dense iron-nickel surface with a harsh grind. It's blindingly bright and insanely hot here, hotter than the surface of the sun, and the pressure would squash any real blade flat. Put the chainsaw aside. For the next planet, you'll need something of a more modest size. You're zooming over to Mars, the last of the rocky inner planets. The knife breaks through Mars's crust. It's thin and solid, made of volcanic basalt rock. As the blade cuts in, fine reddish dust, like cosmic talcum powder, puffs up, drifting everywhere. The crust doesn't crack into big plates like Earth's. It's one big solid shell. Next up, the mantle. Think of it like thick, soft, rocky toothpaste. Not totally solid, but not mushy either. The knife slides through it with some resistance, and you see glowing silicate goo in red and orange shades, swirling around the blade. The mantle is thinner than Earth's, only about 800 to 1100 miles thick, so you don't have to wait long to get to the juicy middle. Finally, you hit the core, a metal mix of iron, nickel, and sulfur. Mars's core is molten, but it's cooler and more chill than Earth's. In any case, it's easy to cut through, no effort needed. We're coming close to Jupiter, the biggest dude in the solar system. Jupiter is a gas giant, basically a giant balloon filled with crazy stuff. As you cut it, you don't hit solid ground at first. Instead, it's all thick, swirling gas, mostly hydrogen, around 90%, and helium. It must feel like slicing into super thick whipped cream that never ends. As you go deeper, the gas gets so squished that it turns into a thick liquid. The blade pushes through layers of swirling storms and colorful clouds that whirl around. Keep going, and the gas becomes metallic hydrogen. The knife slices through a glowing, electrified liquid that crackles around the blade, like you're cutting through electric jelly. Finally, somewhere way deep inside, you reach the core, which might be a molten hot ball of liquid or a giant rock heavier than 14 Earths. Nobody's totally sure. But if you could slice through it, the core would be hotter than 43,000 degrees Fahrenheit. A regular blade would melt instantly or be crushed from all that pressure. It would be pretty tricky to cut open the next planet, not because it's too hard or rocky, but because there's basically nothing to cut through. In Saturn's outer layer, your knife hits thick, swirling gases, mostly hydrogen and helium, but with some funky extras like methane, ammonia, and water vapor. As you cut, a smoggy orange haze puffs out. That's all the sulfur giving Saturn its groovy look. The atmosphere and surface blend together. No hard ground here. As the blade digs deeper, the gas gets squeezed tighter and tighter. Hydrogen starts turning into thick liquid, and your knife leaves trails through this gooey, glowing layer. Keep going down, and suddenly, the liquid gas turns into metallic hydrogen, shiny and electric, crackling around your blade like a sci-fi lightsaber. Deep inside, you might hit a rocky core, but no guarantees. It might even be liquid rock, glowing and swirling beneath all that gas. Next, we're gonna split open an ice giant, Uranus. Its atmosphere has enough methane to give the planet that cool blue-green glow. As your blade moves, a faint icy mist sprays off. It's like slicing through a cold, foggy cloud. Next, you slice into the ice mantle, which makes up about 80% of the planet. But don't think frozen popsicles. This is a thick, hot, gooey soup of water, ammonia, and methane ice. The blade pushes through this dense, slushy ocean with little bubbles and steam escaping as you go. Then, bam! Blade hits the rocky core, small and dense, half as heavy as Earth. It's cooler than most cores, about 9,000 degrees Fahrenheit, which is still crazy hot. The blade scrapes over solid rock with sparks flying off like cutting metal in a cold workshop. Neptune's also crazy cold, but cutting it feels different. When cut, it whips clouds of frozen methane, flying past at 1,200 miles per hour. It feels like slicing through a freezing, super windy blizzard. Next, you plunge into the mantle, a thick, boiling hot soup of liquid water, methane, and ammonia. The knife pushes through this dense stew with bubbles popping and steam hissing. Temperatures here range from 3,000 to 8,500 degrees Fahrenheit. Even deeper, the blade hits Neptune's solid core, mostly iron, metals, and silicates. The blade scrapes along this tough metal center, sparks flying like you're welding the heart of the planet. Now, comment below, which planet was the most satisfying to cut through?
So, planets with two suns, like Tatooine from Star Wars, used to sound like pure fantasy. For decades, scientists believed these systems were too unstable to exist. Two stars tugging at a planet should fling it into space or drop it into one of the suns. Except, it turns out that nature didn't get the memo. Astronomers have found a planet calmly orbiting two stars like it's no big deal. This planet lives closer to its two parent stars than any other directly imaged planet in a binary star system astronomers have ever seen. Now, direct imaging means they saw the planet's light, not just its shadow. The whole system sits about 446 light-years away, so the light we see from it today left before humans ever built modern cities. This space monster is roughly 6 times the mass of Jupiter. And even more surprising, the planet is only about 13 million years old. That sounds ancient until you zoom out a little. Earth is about 4.6 billion years old, which makes this planet basically a newborn in cosmic terms. The two suns of this monster orbit each other incredibly fast and complete a full loop in just 18 Earth days. That means their gravity constantly shifts, yanking space around them like a cosmic washing machine. Even so, the planet stays locked in its path, so it takes it 300 Earth years to finish a single orbit. So nobody fully understands how this planet formed in the first place. When two stars orbit each other this closely, their gravity usually tears apart planet-forming material before anything big can take shape. Scientists have only found a few dozen planets like this so far, and that's nowhere near enough to piece together the full story. To solve the mystery, they need more data. Now, another cool find that still needs more research is a planet so stretched by gravity that it looks like a lemon, not a sphere. This planet is nothing like the calm blue and green worlds we see in space movies. It orbits a pulsar, which is basically a star's corpse. When a massive star expires, it collapses into an ultra-dense object that spins insanely fast and blasts radiation like a cosmic lighthouse. Being near one of those means game over for anything solid. And yet, this planet hangs on, barely. The gravity stretches it, pulling harder on the side facing the pulsar than the far side, like cosmic taffy. And here's where it gets extra unsettling. When scientists analyzed this planet's atmosphere, they didn't find water or oxygen. They found helium and pure carbon. No clouds, no oceans, no chance of life. According to everything we know about planet formation, this world shouldn't exist at all. So it might not be a planet in the normal sense. It could be the exposed core of a star that got shredded, leaving behind something stuck between planet and stellar corpse. That's a pretty scary trend. The line between planets and stars keeps getting blurry. And speaking of scary, meet this guy. This system lives around two red dwarf stars. These two stars orbit each other at a distance similar to how far Jupiter sits from the Sun. Scientists found two Earth-sized planets and a third possible one squeezed right up next to the stars. One planet completes a full year in just over 2 days. Another takes about 3.5 days. The candidate planet orbits even faster. To put that in perspective, these planets sit less than 2 million miles from their star. The Moon sits about 250,000 miles from Earth. So yeah, these worlds are close. When they combined data from space and ground-based telescopes, astronomers realized they were staring at something totally new – planets that transit or pass in front of both stars. Most planets in double-star systems orbit only one star, and this setup shouldn't last long according to the rules of physics. But these planets exist anyway, calmly breaking the rules. So this guy proves that planet formation works in ways we still don't fully understand, and space clearly enjoys messing with our expectations. Now, let's crank up the horror a notch. Astronomers made the first ever 3D map of a planet outside our solar system. And not just any planet. This one is so hot it literally tears water molecules apart. As the planet moved behind its star, the James Webb watched tiny changes in the star's light at different colors or wavelengths. Some colors get absorbed by water vapor, others don't. By stacking all that info together, scientists figured out temperatures at different heights and locations in the planet's atmosphere. And that's how they learned that parts of its atmosphere heat up to nearly 5,000 degrees Fahrenheit, hotter than molten lava. This superhot planet sits about 400 light-years away and weighs around 10 times as much as Jupiter. It races around its star in just 23 hours. 1 year there is basically a day. And because it's so close, the temperatures get so high. Winds try to move heat around, but they totally fail. WASP 18b's atmosphere barely has any water and instead overflows with carbon monoxide. Astronomers once believed water should be common in giant planet atmospheres. This world proves water is optional, not guaranteed. Now, magma worlds are another perfect proof of that. There's a huge group of planets called sub-Neptunes, planets bigger than Earth but smaller than Neptune. For a while, some scientists hoped these worlds were Haitian planets, covered in deep oceans of water or ice, wrapped in thick atmospheres. One famous example was K2-18. Its atmosphere showed methane and carbon dioxide, but almost no ammonia. But as it turned out, lava dissolves ammonia too, so the missing ammonia doesn't prove water at all. It could just mean the planet has a global ocean of magma instead. The researchers modeled how these planets heat up, cool down, and evolve over time. They asked a simple question: do these planets ever cool enough to stop being lava worlds? And the answer was almost never. When they tested thousands of known sub-Neptunes, they say almost all of them are likely lava worlds, not water worlds. In simple terms, these planets don't breathe water vapor, they breathe rock vapor. Their atmospheres come from magma boiling, not oceans evaporating. And that changes everything. Many worlds we once labeled maybe habitable turn into hellscapes the moment you run the numbers honestly. And that means space isn't hiding Earth clones, but mass-producing furnaces and other sorts of monsters. Take this bad boy, for instance. It sits only about 64 light-years away, which is uncomfortably close in cosmic terms, and it's the nearest hot Jupiter to Earth. From afar, it looks stunning, a smooth, deep blue marble floating peacefully in space. But that color hides something absolutely brutal. On this planet, it rains glass, sideways. Winds scream across the atmosphere at around 5,400 miles per hour, fast enough to shred anything instantly. The blue color comes from tiny particles of silicate, the stuff glass is made of, floating in the air. The planet's surface temperature hits about 2,400 degrees Fahrenheit, hot enough to melt rock. That heat turns those silicates into microscopic shards of glass that whip around the planet like a worldwide sandblaster. Standing there wouldn't hurt. You wouldn't exist long enough to ever feel it. And then there's the darkest planet ever found. It reflects less than 1% of the light that hits it. It's darker than coal, darker than black paint. Light just disappears into it. Not all planets even bother with stars at all. Astronomers have found rogue planets, worlds kicked out of their solar systems. These lonely planets drift through space in total darkness, frozen and untethered, with no sunrise ever again. Now, all of this shows us that our universe isn't designed for life. Life survives despite the universe, not because of it. Earth isn't typical, it's lucky. We're only at the beginning of this discovery era. Every year, new telescopes sharpen the picture, and every year, the picture gets stranger. The more clearly we see the universe, the less it resembles our imagination. And that's the most unsettling truth of all.
Imagine, all the planets from the solar system had a meeting and decided that Earth should move to another galaxy. Then what? Well, my friends, if Earth got kicked out of the solar system, let's just say we'd be in for a bumpy ride. As you may know, each planet occupies its own orbit in relation to the Sun, guaranteeing the perfect functioning of our solar system. But it wasn't always like this, though. Billions of years ago, planets and asteroids kept constantly bumping into each other. It took some time before each planet found its own personal orbit, and our system took the formation it has today. Now, as you may know, the most important organizing factor of the solar system is gravity. Gravity attracts every piece of matter to every other piece of matter in the universe, and the bigger the mass, the bigger the gravity. The Sun makes up 99.75% of all the mass in the solar system. It's precisely the Sun's gravitational pull that has kept Earth on a steady and reliable path. But it wouldn't take a surreal interplanetary meeting for Earth to go rogue. This is an actual possibility, an unlikely, but real one. For instance, if any rogue planet or star were to travel close to the solar system, its gravitational force could mess up our planetary organization. And did you know that this has actually happened before? Some 70,000 years ago, a red dwarf passed through the Oort cloud and messed things up. The Oort cloud is an outer circle of space debris located on the edge of our solar system. It lies far beyond Pluto and the Kuiper Belt and surrounds the Sun in a giant spherical shell. Apart from the 8 planets and the Kuiper Belt, there is another asteroid belt between Mars and Jupiter. Now, scientists expect another red dwarf to pass by our solar system. It's an orange star from the constellation of Serpens Cauda. Astronomers expect it to pass near the Sun in about 1.29 million years, at a distance of about 99 billion miles. This star has about 60% of the mass of the Sun, which would be enough to cause a great disturbance in our system. Once the star entered our system, we'd be able to see it in the night sky without any equipment. It would be like watching a small orangish dot appearing in the sky. Over the months, it would grow bigger and bigger until we'd see it during the daytime. At a certain point, it would become so big and bright that we wouldn't be able to look at it directly. Just like people say we shouldn't do with the Sun, but we look at it directly anyways, right? At this moment, the night sky would fill with an eerie red glow, and after a few months, the orange star would start shrinking again, turning smaller than the Sun. But then, wait, the Sun is turning smaller too. Well, yes. The passing of Gliese 170 took Earth out of its orbit, and its gravitational force pulled us out of our natural alignment. Now the Earth will roam through the solar system until it reaches outer space. So, what would happen with our planet if this were to really happen? First, the Earth would leave what is known as the Goldilocks zone, also known as the habitable zone. It's a rather narrow part of the solar system where human life can thrive. What's its success secret? Water in a liquid state. Astronomers have discovered that Mercury also has water, but only in its northern and southern poles, where light never reaches. Pluto, the dwarf planet at the rear end of the solar system, is 30% water, but much of it is hiding under a thick layer of ice. If the Earth ever did leave its privileged place orbiting the Sun, it would travel around the galaxy at its orbital speed of 67,000 miles per hour. That's 1,000 times faster than a cheetah can run. Pretty fast, huh? So, in about more or less a month, humanity would see the red giant Mars on the horizon. By then, we would be getting around 44% of the sunlight we once had. If someone wanted to begin a new civilization, this would be the perfect moment. With reduced sunlight, it would be more difficult for plants to continue doing photosynthesis, so most of the flora on our planet would begin to perish. A few days after leaving Mars's orbit, our planetary spaceship would face its first challenge, traveling through the asteroid belt. It's a collection of small, rocky, metallic bodies. They're basically leftovers from the Big Bang that created our solar system 4.6 billion years ago. So, in a way, it's almost like we were traveling in time, right? Luckily for us, the distance between one asteroid and the next is about 600,000 miles. So, after passing one asteroid, it might take us a while before running into the next. If we make it through this journey intact, then we'll see the first gas giant in our galaxy, Jupiter. Up until this moment, our loyal moon has been following us as we travel inside the solar system. But, Jupiter's huge mass might steal our moon away from us. After all, Jupiter's gravity is twice as strong as Earth's. If our moon did join Jupiter's orbit, it would be no less than its 80th moon. A bit too many moons, if you ask me. At this point in our travels, the Earth's atmospheric temperature would have fallen drastically to around negative 229 degrees Fahrenheit. So life on Earth would only be possible in very specific places. Most of our planet's water would be frozen at this point, but only on the surface. Thanks to the Earth's core activity, it would heat our oceans from below, allowing heat to escape and maintain some water in the liquid state. In fact, the Earth's core would remain active for billions of years after it has left orbit. In this scenario, microbes living near hydrothermal vents would thrive. But perhaps some life would also be possible near the heat provided by thermal vents above the surface, in places like Yellowstone Park. A great option for humanity would be to build cities deep underground. This would be our best bet if we wanted to keep human life on planet Earth. 10 years after our departure, we would be deep into the interstellar voyage. We'd be over 2.8 billion miles from the Sun. Our solar system would be nothing but a distant memory. If you were still living on Earth at that point, then you'd probably be coexisting with great technological advancements. Humans could build entire underground cities using geothermal energy. Maybe we'd even discover how to turn ice into power and create a sustainable and abundant system for fuel. Ice would also be our main source of water, and by then, the transformation process wouldn't be as expensive. Underground crops would thrive, but some plants would be better than others. Moss, fungi, and algae would be some great alternatives, as they are much easier to farm and grow in large numbers. This would mean that most of our diet would be plant-based, as it might be hard to keep grazing animals under the ground. Humanity could go on living thousands of years this way. If Earth happened to pass by some star with a habitable planet, we might even attempt to make a home on another planet. Spaceflight would become easier without the atmosphere in the way. So, the idea of venturing into other planets would no longer seem too surreal in this scenario. The only thing that we would rather not happen to us is Earth running into a black hole. If that happened, let's just say we'd all be turned into spaghetti. Not literally, but we would go through a process that is called spaghettification. In this case, planet Earth, and everyone still living on it, would be vertically stretched up to the point of, vanishing. But that's the subject of another video. Fortunately, even if all this could be true, we wouldn't be caught by surprise. Thanks to scientific and technological advancements, we would be able to predict if a star were to pass too close to our home planet. And even if we couldn't stop a star, we would most certainly manage to do everything to prepare. So, who knows? Maybe the future generations will be watching this video, surprised at how precisely we figured the future out.
Imagine a planet with no sun. Once it became unwanted in its own star systems and got ejected into the soulless emptiness of space. Or maybe it didn't even have its own star system. It was born lonely. I'm talking about a rogue planet, Such planets are also called orphans, nomads, unbound, and sunless. It all sounds pretty sad, doesn't it? The rogue planet in question doesn't have sunlight. The never-ending night reigns on its surfaces. No light means no warmth, and that's why there isn't any kind of life on this frozen world. But believe me, this isn't the scariest part. One day, a rogue planet might push Earth out of its cozy spot near the Sun. You see, we live in the habitable zone of our star. It means that our planet is such a distance from the Sun that water can't exist on its surface in its liquid form. But an interstellar intruder could mess it up for us. If a rogue planet somehow got into our solar system and we didn't manage to stop its imminent approach, it would likely crash into our beautiful blue planet. And then Earth could be pushed out of its orbit, retreating to an extreme orbit farther from the Sun. Now let's imagine what would happen to our world if a rogue planet the size of Mars collided with us. Most likely, people would react with panic and desperation. We've had a few sad examples of space intruders wiping more than 3/4 of all life forms off the face of the planet. One more similar event would be devastating. The immediate impact, pardon the pun, of such a collision would be truly catastrophic. It would lead to massive losses of life and destruction of huge areas of the planet. At first, people would focus on rescue and recovery efforts, but soon it would become obvious that the world is beyond salvation. The climate all over the planet would start getting colder and colder. Plus, the farther our planet would be from the Sun, the weaker the star's gravitational pull on our planet would be. In the end, our beautiful Earth would get too far away from its main source of light and heat. It would turn into a lifeless piece of rock covered with a thick layer of ice. Well, that's rather grim. But what if humanity had foreseen this catastrophe and prepared for it in advance? What would our life look like, and where would we live after the cosmic disaster? If, by the time of the collision, people had already established a colony on Mars, we would probably have some time to leave Earth and set off for the Red Planet. But would it even be possible to transform this distant world so that it became capable of supporting human life? Oh, and it would no doubt be an enormous feat. You see, Mars is an extremely dangerous place to us. If you somehow teleported there without any protective suit, the gas in your blood would instantly turn into bubbles, which is not good. Add oxygen deprivation, cold exposure, and radiation poisoning to the equation, well, you get the picture. But if a rogue planet destroyed life on Earth, we'd have no choice. We would need to create a stronger magnetosphere on the Red Planet to shield it from the Sun's ultraviolet radiation. For the same reason, Mars would need a thicker atmosphere too. Right now, the Martian atmosphere is almost entirely composed of carbon dioxide with tiny amounts of oxygen. This air is not suitable for people. For humans to live there comfortably, Mars would also need to be warmer. And if we managed to somehow warm the planet up, we'd also be able to release frozen carbon dioxide. At the moment, there are vast reserves of this gas at the Red Planet's polar caps and other areas. It would help the atmosphere to become thicker, making it possible for water to exist on the surface of the planet. Also, we would need some place to live. NASA has been experimenting with light inflatable habitats, but obviously it wouldn't be a long-term solution. At the same time, it's incredibly expensive to deliver building materials to Mars, especially if we were pressed for time, escaping our poor collapsing Earth. So instead of shipping prefabricated construction elements to the Red Planet, we could grow them right on its surface. We could achieve this with the help of fungi and cyanobacteria. They can produce tons of biominerals like calcium carbonate, as well as biopolymers. They would be able to glue Martian rocky material covering bedrock into real building blocks. In other words, bricks on Mars would be growing on their own, and we'd only have to assemble them into different structures, like walls, floors, and even furniture. At the same time, such a young colony wouldn't be able to survive for more than a generation without getting more supplies from Earth. But, as you understand, this option would be unavailable. Then, maybe people would move to colonies located on numerous space stations located far enough from the impact event. In this case, we would be able to avoid the destruction. But such habitats would have to be large enough to support farming and medical facilities, power generating factories, educational establishments, and many more. And it would be hard work to support such stations without necessary supplies, when a simple equipment breakdown could turn into an unsolvable problem. But let's imagine that our descendants decided to find Earth several thousand years later and succeeded. As you remember, our planet would have changed its position, hanging out way further from the Sun. Now, hopefully, Earth would have regained its magnetic field after the impact, as well as a little of its original atmosphere. But those who would return to Earth would need water, oxygen, and sufficient atmospheric pressure. And while the new pressure on the planet would probably be suitable for life, most likely there wouldn't be enough oxygen to support unaided breathing. To get a new supply of oxygen, people would need photosynthetic bacteria. Would we find any on the deserted planet? Probably yes. Most, or at least some bacteria would survive, maybe somewhere deep under the surface, maybe in the depths of the oceans if any remained on the planet. Tardigrades, the most indestructible animals on Earth, might also survive and greet people returning home. These tiny water bears can survive for up to 30 years without food, live in volcanoes, and even endure the vacuum of the cosmos. So these life forms, bacteria and tardigrades, could likely thrive and multiply without any predators to slow this process down. That's good to know, but what would we eat on the newly inhabited planet? Tardigrades are not a diet a person could live on. Well, we could still find some frozen seeds remaining on the planet, or we could keep them on our space stations. Earth's soil could be filled with nutrients remaining after the catastrophic events of the past. People would start planting seeds, trying to get used to the harsh conditions of life on the once deserted planet. And still, it would be better than soulless space stations. Luckily, a rogue planet is unlikely, not only to hit Earth, but even to come close to our planet. The appearances of such space travelers are extremely rare, and with how fast our technologies are developing these days, astronomers would spot such a large celestial object appearing in the neighborhood or even in the entire solar system. It would happen long before a rogue planet turned into a threat to our planet. If it got too close to us, we would use one of the methods developed to prevent asteroids from hitting the surface of the planet. There are quite a few. For example, a kinetic impactor. This technique requires hitting an asteroid to make it change its orbit until it's no longer a threat to our planet. Or we could use a gravity tractor asteroid deflection method. That's when a robotic probe meets a space rock, or in our case, a rogue planet, and accompanies it for a few months or even years. Over time, the spaceship's gravity starts affecting the space body, adjusting its trajectory. There's even spray painting celestial objects. I'm not kidding. Darker surfaces tend to reflect less light, while lighter reflect more. Toying with these features, we can make a rogue planet change its course. If we found enough paint to cover an entire planet, that is.
3, 2, 1, 0.
In 1977, NASA sent the Voyager spacecraft to explore the outer parts of the solar system and the space beyond. And at one point, the probes ran into something totally nightmarish: a blazing wall of fire measuring temperatures from 54,000 to 90,000 degrees Fahrenheit. Well, did the probes manage to survive these intense conditions? We'll find out soon. Meanwhile, there are several ways to think about where the solar system ends. One way is to say it ends where the planets stop. Another way is connected to the Oort cloud. That's a giant group of icy objects far beyond the planets, the farthest region of the solar system. It is extremely distant, maybe a quarter to halfway to the nearest star. To understand such huge distances, scientists often use something called the astronomical unit, or AU. 1 AU is the distance between Earth and the Sun. For comparison, Pluto orbits between about 30 to 50 AU from the Sun. The inner edge of the Oort cloud is thought to be much farther away, and the outer edge could be even further away. These distances are very hard to imagine. My little brain sputters when considering such. Now, we can also measure them in time instead of miles. NASA's Voyager 1 spacecraft makes almost 1 million miles per day. At that speed, it would take about 300 years to reach the Oort cloud, and maybe 30,000 years to reach its outer edge. Now, one more way to define the edge of the solar system is by the Sun's gravity. It might be the area where the Sun can still pull objects back toward it. And finally, we can define it by considering the heliopause, the boundary where the Sun's influence ends. You see, the Sun constantly sends out charged particles in a flow called the solar wind. This wind moves past all the planets and reaches about 3 times the distance to Pluto. The solar wind creates a giant bubble around the Sun and planets called the heliosphere. The heliopause is the outer edge of this bubble, where the solar wind meets the wind coming from other stars, called the interstellar wind. Here, the pressures from the solar wind and the interstellar wind balance each other. This causes the solar wind to turn back and flow along the tail of the heliosphere. As the heliosphere moves through space, it creates a bow shock, similar to the wave that forms in front of a ship moving through the water. So, depending on how you define it, by planets, by the Oort cloud, by gravity, or by the Sun's magnetic influence, the edge of the solar system can mean very different distances. But if we talk about the Voyagers, they came across something intense. It was something we could probably call a wall of fire, blazing heat and intense temperatures. The 2 probes became the first spacecraft to travel beyond the heliosphere and cross the heliopause. Before the Voyager spacecraft reached the heliopause, scientists did not know exactly where this boundary would be. But the fact that the 2 spacecraft crossed it at different distances helped confirm some predictions about the heliopause. Scientists did expect that the edge of the heliosphere could move as the Sun's activity changes, a bit like a lung expanding and contracting as we breathe. And the fact that Voyager 1 and Voyager 2 encountered the heliopause at different distances matched this expectation. The heliopause is not a hard edge or solid wall, but the nickname Wall of Fire actually matches the nature of that insane region. Both spacecraft measured extremely high temperatures there, around 30,000 to 50,000 Kelvin, or 54,000 to 90,000 degrees Fahrenheit. Despite these extreme temperatures, the spacecraft were safe. The particles in this region are very far apart, so collisions are rare and not enough heat could reach the spacecraft to harm them. Nearly 50 years after their launch, Voyagers 1 and 2 continued to send back data from beyond the heliopause. They are the only 2 spacecraft that have crossed this boundary so far. Together, they have already made several curious discoveries about space outside the solar system. For example, Voyager 2's magnetic field measurements confirmed a surprising result from Voyager 1. Just beyond the heliopause, the magnetic field lines are aligned with the magnetic field inside the heliosphere. Before Voyager 2, scientists only had one measurement from Voyager 1, so they could not be sure whether this alignment was real or just a coincidence. Voyager 2 confirmed that the alignment was real. The magnetic fields inside and just outside the heliopause apparently run in parallel. These discoveries give scientists important information about the structure and behavior of space beyond the solar system. Now, let's dig a little deeper into the Voyager program itself. It's made up of 2 spacecraft, Voyager 1 and, wait for it, Voyager 2. Even though Voyager 2 was launched first in August 1977, Voyager 1 took off just 2 weeks later on a faster, more direct path. These 2 spacecraft have been traveling for more than 40 years, exploring worlds no human will ever walk on, at least in the near future. The 2 Voyager spacecraft are nearly identical. Each has a large radio dish that is 12 feet across. This dish sends data back to Earth. They also have 16 thrusters to control their direction and make sure the dishes always point toward our planet. The thrusters use special hydrazine fuel, and the spacecraft's electronics are powered by thermoelectric generators that run on plutonium. Each Voyager carries 11 scientific instruments. About half of them were made specifically to study planets, and most of those are now turned off. The turned-off instruments include several cameras, spectrometers, and 2 radio-based experiments. During their long journeys through the solar system, the Voyagers took tens of thousands of images and measurements. This data has changed what we know about the outer planets. When the Voyagers reached Jupiter, they gave us our first detailed look at the planet's atmosphere. They showed that the Great Red Spot was a huge storm spinning counterclockwise and interacting with smaller storms nearby. The Voyagers also discovered a faint dusty ring around Jupiter. They studied Jupiter's moons, too. They found volcanoes on Io, saw linear features on Europa that hinted at a hidden ocean beneath its icy surface, and confirmed that Ganymede is the largest moon in the solar system, larger even than Saturn's moon Titan. Next, the spacecraft flew past Saturn. They measured the planet's atmosphere and studied its famous rings, discovering gaps and waves we still see today. Voyager 1 looked through Titan's thick haze and suggested that the moon might have liquid hydrocarbons on its surface. It was later confirmed by other missions. Voyager 1 also found 3 new moons orbiting Saturn: Atlas, Prometheus, and Pandora. So that's where she ended up. After Saturn, Voyager 1 continued out of the solar system, while Voyager 2 headed toward Uranus. Voyager 2 discovered 11 new moons and 2 new rings there. It also observed strange features, such as Uranus's unusual magnetic field and a surprisingly small temperature difference between its equators and poles. Voyager 2's final planetary stop was Neptune. It happened 12 years after leaving Earth. There, it discovered 6 small moons and rings around the planet. It studied Neptune's atmosphere and magnetic field, and observed volcanic vents on Triton, Neptune's largest moon. After this, Voyager 2 joined Voyager 1 on its journey toward interstellar space. Voyager 1 entered interstellar space in August 2012, and Voyager 2 joined it in November 2018. These missions helped scientists measure the edge of our solar system, about 11 billion miles from the Sun. The spacecraft still sends back data about this mysterious region. By the way, after its planetary visits, Voyager 1 took the famous pale blue dot photo of Earth from about 3.7 billion miles away. Today, Voyager 1 is about 15.8 billion miles from Earth, and Voyager 2 is about 13.1 billion miles away. Each Voyager carries a golden record, a time capsule from Earth for other civilizations it might meet. The record covers include instructions for playing it, a map showing Earth's location, and a drawing of a hydrogen atom. The records are cleverly plated with uranium, so the decay of the uranium could help discoverers figure out when the record was made. The records contain 115 images showing Earth, humans, animals, plants, and our solar system. They include natural sounds like waves and birdsong, greetings in 55 languages, brainwave recordings, and a mix of music, ranging from Beethoven to Chuck Berry and folk songs. Wow! Astronomers just discovered that the solar system is moving way faster than it should. One trusted cosmic speedometer says we're cruising at a normal pace, but a new one says we're racing through space at a speed that should not even be possible if our physics are right. So it seems that either something out there is pulling us, or one of our basic ideas about the universe is seriously wrong. Now, when we move, things in front of us react more than things behind us. For example, if we walk through falling snow, the flakes hit our faces, not the backs of our heads. Ride a bike, and the air pushes harder in front, while the air behind feels calm. The front gets busier, the back gets quieter. That difference alone is enough to tell our brain that we are in motion. In cosmology, this front versus back pattern has a technical name. It's called a kinematic dipole. Astronomers use this principle when they measure how fast our solar system is moving through space. To do this on a cosmic scale, astronomers look at the sky the way we look at the world when we start moving. Only instead of snowflakes or air, they use distant galaxies. These galaxies sit so far away they barely change over billions of years, so they work like tiny markers frozen in place, perfect for spotting the difference between what's in front and what's behind. If the universe is smooth on the biggest scales, you'd expect the number of galaxies in each direction to be about the same. It doesn't really matter where the Milky Way is pointing or how we're spinning. The sky should balance out. But if our solar system is moving, One side might seem a bit more crowded because we're flying into it. It's the same trick as noticing more rain hitting the front of your jacket when you run forward. So, astronomers created huge maps of the sky using radio telescopes, which are good at picking up galaxies that shine in radio waves. Radio waves travel through dust, so the view stays clean. They counted how many radio galaxies appear in every direction to see if one side of the sky really is busier than the rest. And that's when they noticed something strange. The side of the sky we're moving toward was much more crowded than expected, like someone stuffed extra galaxies into that patch. This could mean we're moving faster than the standard model allows, or the galaxies are unevenly spread. We already know our motion from another source, the cosmic microwave background. It's the leftover glow from the Big Bang, and it works like a giant universal speedometer. For decades, it's given us a stable measurement of how fast the universe is moving. But this new result does not match that value at all. That extra crowding in the sky isn't supposed to exist at that level. Our best model of the universe says that when we zoom out far enough, the cosmos should look smooth and even. This result makes scientists scratch their heads. The pattern in the radio galaxy map was much stronger and more lopsided than expected. It lined up almost perfectly with the direction we're already moving, as if something out there was pulling harder than anything we've put into our models. Now, scientists just didn't look at one map and call it a day. They checked the result using several sky surveys made with different kinds of radio telescopes. One of those was LOFAR, a giant web of antennas spread across Europe that listens to the lowest, faintest radio signals, combined with two other large radio surveys. It's like taking 3 pictures of the same scene using 3 totally different cameras. If one of them added a strange color or distortion, the other 2 would catch it. But here, all 3 showed the same odd result. The dipole they measured is about 3.7 times stronger than what the standard model of the universe predicts. That's not a small calibration problem. That's a "your calculator must be broken" kind of difference. To understand how impossible this is, imagine checking 2 speedometers at the same time. One of them is the reliable one we always trust. That's the cosmic microwave background in this situation. It says we're moving at a normal speed. But the second speedometer suddenly claims we're going more than 3 times faster, like 200 miles per hour inside a parking lot. We would know something was off. Both readings can't be right. This is the problem. The CMB gives a solid decades-old speed, but the new radio galaxy result is showing something different. 2 measures that should match are telling very different stories. So, what could be the reason for these broken calculations? Well, one idea is that the universe is not as smooth or even on large scales as our model assumes. We expect that if we zoom out far enough, everything should start looking roughly the same. But this result hints that the large-scale universe might be more uneven than that. Maybe some huge regions are a bit richer in galaxies, while others are emptier, and those differences add up across the sky, creating a dipole stronger than the standard model predicts. If that is the case, the extra radio galaxies are not a mistake. They are a sign that the cosmos does not follow the straightforward pattern our model assumes. Now, another idea is that something genuinely huge and nearby might be pulling on our whole region of space. No, sadly, not some giant space monster messing with our system from another dimension. The universe already has giant walls of galaxies, long chains of superclusters, huge clumps of dark matter, and massive empty voids that stretch for hundreds of millions of light-years. These things are so large that they can change how entire regions of space move. It's not a sudden yank, more like a slow, constant tug on everything nearby over a very long time. If there's something like that close enough, we can't see it. A wide stretch of space is hidden behind the Milky Way's own dust and bright stars. Astronomers call this the zone of avoidance because our telescopes can barely look at what sits behind that glowing band. We already know there's a large concentration of mass in that blocked region called the Great Attractor, which was my nickname in high school. And some researchers think something even larger could be sitting deeper in the same direction. Now, if that's true, then the strange pattern we see in radio galaxies might not be a mistake. It could be the first hint that something huge is tugging on our whole galaxy region, and we simply haven't mapped that part of space yet. Finally, the third idea is that something is off with the model we use to describe how the universe works. A model is just a big set of rules, like a recipe. Our current one explains dark matter, dark energy, how galaxies spread out, and how the cosmos changes over time, and it expects the universe to behave in a smooth, predictable way on huge scales. The radio galaxy result does not fit that picture. It behaves like a number that refuses to match the rest of the equation, so scientists have to take it seriously. It could mean that matter and energy spread across space in a way we did not build into the model. That would not break physics. It would just mean the rules need an update. So, what happens next? A bunch of powerful new surveys are coming online, and even though they weren't built specifically to solve the dipole problem, they're going to be extremely useful for checking it. The Square Kilometer Array and the Rubin Observatory are all going to map galaxies in way more detail than the older surveys we use now. With cleaner, deeper data, these instruments may help us determine whether the strong dipole is real or fades away when we look at it with better tools. None of these are special missions made just for this question, but the next round of observations will test it naturally. If this strange motion turns out to be real, then something big is shaping our whole region of space. If it's not, then we just learned something important about how easy it is to fool ourselves with patterns in the sky. Either way, we get one step closer to understanding the universe and its puzzles.
For thousands of years, people knew only about the planets Mercury, Venus, Mars, Jupiter, and Saturn, which they could see using simple telescopes, or even by the naked eye if conditions were good. But in the late 18th century, a famous astronomer named Sir William Herschel discovered a new planet that was icy blue in color. At first, people thought it was a star, but later they realized it was a planet. Today, we know it as Uranus, a planet that's more than 19 times farther away from the Sun than Earth. It's so far away that it takes Uranus 84 years to complete one trip around the Sun. This astronomer also discovered many other interesting things in space, like double stars and nebulae. In the mid-1800s, scientists noticed something pulled Uranus and strangely tugged its orbit. They thought there must be another planet out there, and they used math to predict where it would be. Finally, in 1846, they found Neptune using a telescope. It was too faint to see with the naked eye because it was too far away from the Sun. It was all so exciting. Who knows how many other planets could be there, lurking in the darkness of our solar system? Back in the mid-1800s, astronomers noticed something unusual was happening in the sky. A small rocky planet named Mercury was behaving strangely. It didn't follow the predictable orbit that was expected of it. One of the astronomers was a brilliant French scientist named Urbain Le Verrier. He came up with a theory that there could be another planet in our solar system no one had yet discovered. It would be located somewhere between Mercury and the Sun. This hypothetical planet, which he named Vulcan after the Roman god of fire, would have an incredibly hot surface, and it could be a potential explanation for Mercury's strange behavior. He never surely claimed Vulcan was really the one thing disturbing the orbit of Mercury. But, excited by the possibility of discovering a new planet, astronomers all over the world took the idea of Vulcan. For a planet that didn't exist, people committed to developing ideas and getting information about it. Some scientists didn't think it was likely that they had missed another planet as big as Mercury. It would have been hard not to see it by then. But there was a tiny chance of a smaller planet existing inside Mercury's orbit that was too close to the Sun, so no one could see it. One theory said it was about 13 million miles away from the Sun. Mercury is the planet with the most eccentric orbit in our solar system, but the closest point it gets to the Sun is about 28.5 million miles. This means Vulcan would be under half of that distance. The theory moved on, saying that if Vulcan existed, it would orbit the Sun every 19 days and 18 hours, and its path would be tilted about 12 degrees relative to the path of other planets in our solar system. Vulcan's position at its furthest point from the Sun would still be too close to the Sun to be seen with the naked eye, even during twilight. The only chance of seeing Vulcan would be during a solar eclipse, or when it passed in front of the Sun, which, as the theory said, would be 2 to 4 times a year. They had a theory that this mysterious planet was so close to the Sun that it could only be seen during a total solar eclipse when the Moon blocked out the Sun's blinding glare. So, every time there was an eclipse, scientists would peer at the Sun, hoping to catch a glimpse of Vulcan. They were trying really hard, but no matter what, they couldn't find this mysterious planet. Some astronomers claimed to have spotted it during eclipses, but no one could ever confirm or find evidence for that. The theory of Vulcan was left waiting for some better times. Einstein had a different idea. You know about his theory of general relativity, right? That's where he claimed gravity wasn't some sort of natural force, but a result of space-time curved because of the presence of giant space objects, like planets and stars. Planets circle around the Sun in their usual orbit because space-time is curved. That means the planets are kind of falling towards the central star of our solar system. And Einstein tried to explain Mercury's unusual orbit using his own theory of relativity. Unlike the other planets in our solar system, Mercury's orbit wasn't that circular. Instead, it seemed to wobble slightly, as if there was an invisible force pulling it away. Einstein said this could be happening because the massive gravity of our Sun was actually curving the fabric of space-time around it. He claimed it's possible this changed Mercury's orbit a little bit. It took the scientific community a while to test this theory, but it eventually seemed like the most plausible explanation. Even though Einstein's theory gave us a more elegant explanation for Mercury's strange orbit, some scientists were still holding out hope for Vulcan. It was especially hard to let go of the idea of Vulcan because Mercury is also the planet that's really hard to see from where we're standing. But later, more and more scientists started accepting Einstein's theory above their imagination. And they would observe a total solar eclipse specifically to test Einstein's theory of relativity, not because of Vulcan. And Vulcan is not the only hypothetical planet everyone was talking about. In the newer age, some believe there could be a mysterious planet lurking in the outer part of our solar system. But this one is more likely to exist. No one has seen it directly yet, but computer simulations show this so-called Planet 9, or Planet X, is probably somewhere there beyond Neptune. Neptune and Planet X could be similar in size. Planet X could be 10 times more massive than Earth and circles around our Sun in an elongated shape, which is on average 20 times farther from the Sun than Neptune. A year there may last between 10,000 to 20,000 Earth years. By comparison, a year on Neptune lasts 165 Earth years. Something this big moving out there beyond Neptune could explain the unusual orbits of smaller objects in the Kuiper Belt. The Kuiper Belt is the area of our solar system beyond Neptune and where it orbits. And there are most likely many asteroids, comets, and some other smaller bodies there, mostly made of ice. There was another hypothetical planet called Nibiru. Remember those rumors that the world could end back in 2012? One of the popular scenarios was Nibiru, which some claimed would hit our home planet at the end of the year. Of course, nothing happened. We're still here, all set and good, but the idea of Nibiru seemed interesting. Stories started in the 1970s when a man named Zecharia Sitchin mentioned Nibiru in his book, The 12th Planet, claiming it orbits the Sun every 3,600 years. But there's no chance a planet with such an eccentric orbit wouldn't disrupt other planets in our solar system with its gravity. And if it was really coming that close to Earth in 2012, we were supposed to be able to see it with the naked eye. Some simple calculations showed Nibiru would have been nearly as bright as Mars at its dimmest and brighter than the faintest stars you see from a city. Oh well, maybe we'll have more luck in the next 3,500 and something years. In 2011, a comet named Elenin appeared that many people thought could be Nibiru. But when you're looking at comets and planets through a telescope, you see they appear differently. A comet has a coma, which is a gas atmosphere, together with a tail, something a planet doesn't have. Plus, this comet didn't slam into the Earth. It came too close to our Sun and fell apart. The leftover pieces will continue moving on their way to the outer solar system for the next 12,000 years.
The Hubble Space Telescope was put into a low Earth orbit in 1990. If you think about it, it's had over 30 years of experience looking at various space objects. It was named after astronomer Edwin Hubble and was built by NASA. It is also part of a group of devices called NASA's Great Observatories, along with the Compton Gamma Ray Observatory, the Chandra X-ray Observatory, and the Spitzer Space Telescope. The Hubble Space Telescope was built to explore the universe and answer some of its biggest questions, such as how galaxies form and evolve, and how the universe itself has changed over time. The telescope has made many important discoveries, including providing evidence of the existence of dark matter and helping to determine the rate of expansion of the universe. One of the most famous images taken by the Hubble Space Telescope is the Pillars of Creation. It's a photo of a region of the Eagle Nebula, where new stars are born. The photo, which was taken in 1995, shows massive pillars of gas and dust towering above the nebula. It has become one of the most iconic images of the universe. The Hubble Space Telescope continues to operate and make important scientific discoveries, despite some initial technical difficulties. In 1993, a problem with the telescope's main mirror was discovered, which affected its ability to focus light properly. A repair mission was sent to the telescope in 1994 to fix the problem, and since then, the telescope has continued to work perfectly. One of the more interesting discoveries made by this amazing telescope is actually pretty recent. A report based on the data from the Hubble Space Telescope shows that there is a faint glow in space around the solar system that cannot be explained by anything we know to exist. Because they have yet to figure out the source, astronomers call this mysterious glow ghost light. We don't know that this light is not coming from the stars or galaxies near the solar system, nor is it coming from dust on the solar system's plane. The researchers aren't sure what the source of the light is, but they think it might be tiny particles of dust and ice left by comets. But it's only a theory that has not yet been confirmed. When we study the universe, we often find bright things like planets, stars, and galaxies. But from time to time, we discover some light coming from places where we didn't expect to see it, like from between planets. This light may be coming from deep within our solar system, and it may be a new phenomenon that hasn't been studied before. In other words, there may be something at the center of our galaxy that produces a lot of light. Spacecraft Voyager 1 also captured images showing a lot of light coming from the edge of our solar system. How come we haven't noticed this until now? Well, because most of the light in pictures taken by the Hubble telescope comes from things close to Earth. But people usually ignore this light because they're interested in things like stars and galaxies that are farther away. We've never actually looked closely at the amount of light in the universe and where it comes from. Scientists have been using the Hubble to find faint galaxies that may have been missed before and which may be the source of this dim glow. They found that there are not enough such galaxies to account for extra light in the sky. It's not a lot of light, though. It's like the glow from 10 fireflies. But it doesn't make it less important. It shows that we may be missing something. Let's look at some other important discoveries we've made with the help of Hubble. Like dark matter, which we can't see but know is there because of its effect on gravity. It makes up for about 23% of the universe. By looking at how it affects light, the Hubble telescope helped make 3D maps of where dark matter is. These maps show that dark matter seems to be getting clumpier over time, which means it behaves very similarly to how gravity does. The Hubble telescope also discovered 2 new moons around Pluto, named Nix and Hydra, and studied the dwarf planet's changing surface. Additionally, it's found the mass of planet Eris, which is larger than Pluto. This helps scientists realize there may be similar objects in the Kuiper Belt, a region outside our solar system. This led to Pluto being reclassified as a dwarf planet. Further observations of these distant objects could help us understand the evolution of our solar system. Gamma-ray bursts are the most powerful explosions in the universe, and for a long time, no one knew where they had been coming from. Hubble helped us find out that these bursts happen in galaxies, producing a lot of stars and having few heavy elements. This suggests that gamma-ray bursts happen when big stars collapse into black holes. These galaxies have lots of big stars that fall apart quickly, and the stars there don't have much heavy stuff, so they can turn into black holes. In 1994, the Shoemaker-Levy 9 comet collided with Jupiter. Hubble captured the whole event in detail, like a resourceful journalist. The impact broke the comet into a lot of small pieces, which resulted in 21 other visible collisions. The largest impact created a fireball and a dark spot on Jupiter's surface. Hubble's observations not only sparked public interest in cosmic impacts, but also provided new insights into Jupiter's atmosphere. To move forward with our list of discoveries made by the Hubble telescope, we also need to talk about black holes. There are points in space where gravity has so much force that even light cannot escape it. The gravity becomes so strong that matter gets squeezed into a very small space. We know that this can happen when a star, like the Sun, nears the end of its life. At the beginning of its life, a star's hydrogen ignites in its dense hot core. Because of gravity, it tries to draw its own mass into a tiny point. As long as it has the energy generated by the hydrogen fusion, it also pushes outward. If we look at it this way, the life of a star depends on a delicate balance between these forces, and it can last millions or even billions of years. Once that energy is exhausted, the only force remaining is that of gravity. So, some stars become black holes. Since light itself cannot escape its pull, we can't visualize black holes. For the human eye, they are invisible. We need special tools and unique telescopes to help us point them out in the universe. Hubble found that most galaxies with a central bulge of stars likely have supermassive black holes. It also noticed a strong connection between the size of these black holes and their host galaxies, which might help us understand how the universe has changed over time. Then, what is a supermassive black hole, you might ask? Go ahead, ask it. It is a very large black hole that is typically found at the center of a galaxy. It is millions or even billions of times more massive than our Sun. These black holes are so powerful that they can swallow stars and even entire galaxies. Scientists are still exploring these mysterious objects, but they believe that they play a crucial role in the formation and evolution of galaxies. Now, before Hubble, we really didn't know how old the universe was. It often led to weird paradoxes, like the one where stars discovered by astronomers were older than the universe itself. But by figuring out the approximate rate at which the universe is expanding, Hubble helped us narrow down its age, which is about 13.75 billion years. Trying to figure out the exact age of the universe is an important question. That's because most astronomers think that the universe has not existed forever, but appeared in one really hot and dense fireball called the Big Bang. I wasn't around then.
Among all the planets of the solar system, our Earth is unique, since it's the only one that has developed life. But what if we got a competitor? What if a second Earth appeared out of nowhere? Then there would be 2 different scenarios. The first is the destruction of both planets, and the second has an unexpected but pretty logical ending. But let's start with the catastrophic scenario. The second Earth with the same conditions could only exist if it received absolutely the same amount of sunlight as our planet. The orbit that our Earth follows is perfect for getting the necessary amount of solar heat. If we were a little further away, the entire surface of our planet would resemble Antarctica. And if Earth were a little closer to the Sun, we'd all live in a huge desert, inhabited by very few living beings. So, for the second Earth to be identical to ours, it would need to follow the orbit of our planet. Two massive objects can exist close to each other. The union of Earth and the Moon is a great example. But if the second object was as heavy and huge as our planet, there wouldn't be enough space for both of them. The gravity of two Earths would be a huge problem. The two worlds would collide because they would be pulled toward each other. This process would last for hundreds of millions of years. And in the end, the two planets would transform into one giant world. And their remnants would be flying around the newly formed planet, resembling the rings around Saturn. Or one of the planets would push the other out of its orbit. In this case, one of the Earths would hurtle toward the Sun and burn like a match in its atmosphere. It's also important to remember that Earth is moving at a speed of 67,000 miles per hour at all times. This is more than 80 times faster than the speed of sound. And now, imagine two huge planets that are flying toward each other at such a speed. Even a microscopic organism living in the mouth of a volcano wouldn't stand a chance to survive the collision of two Earths. Even the Moon would be torn to pieces by the blast wave. But let's imagine that Earth's twin is following another orbit, somewhere between Mars and Earth. Even in this situation, people's lives would change forever. By the way, the theory that Earth might have a twin appeared long ago. Scientists of the past believed that the second planet could be hiding on the opposite side of the Sun. Thanks to modern technologies in astronomy, we know this theory isn't true. Otherwise, our telescopes and other equipment would have already caught some signals from this planet. Scientists study space objects thousands of light years away from us, so they would definitely notice another world in the neighborhood. But anyway, let's imagine that the second Earth does exist, and we've discovered it recently. The entire field of astronomy and astrophysics will immediately receive hundreds of billions of dollars in funding. The study of Earth's twin will become a priority goal for people. Experts will put forward hundreds of hypotheses about what the second Earth looks like and what's happening there. The planet is almost at the same distance from the Sun as we are. This means the weather must be the same there. Soon, scientists find out that Earth's doppelganger has liquid water and continents, but they aren't like ours. Their shapes and location are different. Most likely, life exists there too. But what is its origin? There's a hypothesis that life on our planet appeared thanks to amino acids brought here by a meteorite. It's highly improbable that the same thing happened to another world. Life most likely emerged there in a completely different way. Perhaps the fish didn't get out of the water on that planet, and the first intelligent creatures appeared in the ocean. These could be amphibians with scales and fins, or octopus-like monsters with huge tentacles. Fish on the second Earth could have come out of the water and grown limbs. But what if they didn't like walking on the ground? Then, this world might be inhabited by intelligent bird people. Or, life could have originated deep in the soil. Then evolution would create humanoid moles, or highly developed worms. To find out for sure, scientists send a rover there. A similar mission to Mars was a success, so there shouldn't be any problems with this one. People on Earth are waiting. What will the rover find on the other side? It will take several years for the ship to get there. Strangely, 2 days after the launch, it returns. But wait, this is not our space probe! All this time, the inhabitants of the second Earth have been watching our planet too. At one point, they also sent a probe. It's made of the same materials as ours. It has a camera and a recording device. But people are worried because the rover looks similar to a mechanical spider. Can it be that giant tarantulas live in that world? Scientists understand that we need to communicate. We send our guests a radio signal with some information about our civilization. They catch this message and send their own. It contains strange symbols that resemble scratches. Linguists all over the world are trying to decipher it. Meanwhile, astronomers send the guests a recording of human speech. A few days later, our satellites catch a message from our space neighbors with their voices. Scientists are about to play the recording. The whole world is listening with bated breath. And it's a growl. A terrible and absolutely incomprehensible growl. It has pauses and an unusual rhythm, but it's nothing resembling human speech. The whole planet is panicking. All countries are preparing for an invasion. The most important thing now is to build shields to protect the planet. No one can decrypt the message. It's possible that our neighbors can't understand us either. People make a last attempt to establish some contact. We send a video to explain to our guests with the help of gestures and signs that we only want peace and collaboration. The answer doesn't take long to wait. Our satellite receives their video file. Scientists play back the recording, and it's shocking! We see dinosaurs in robotic suits! Life on the second Earth has been developing in the same way as on our planet. But the infamous colossal meteorite didn't fall there. Over millions of years of evolution, dinosaurs have become sentient. In the video, they're growling and pointing with their claws at the picture of our Earth. Then they start growling even more loudly, and is it laughter? The recording ends. People consider this the announcement of the invasion. Several years have passed. During this time, scientists have exchanged messages with dinosaurs several times, and it seems we're beginning to understand them. It turns out that the reptiles also want peace. They say that their planet was once inhabited by humanoids similar to humans, but a massive flood wiped them away. Dinosaurs managed to survive and evolve into intelligent beings. It will take many years before people set foot on their planet, and when this happens, humanity will feel relieved, realizing that we're not alone. But what if there was no intelligent life on the second Earth? People would also be happy. We would know that we'd always have another home. Perhaps we'd start exploring Earth's twin right away, or begin mining its resources to replenish ours. In any case, our lives wouldn't change immediately, because that land would be too far away from our planet. Dozens of generations would pass before people begin settling on the second Earth. Our homeland planet would be losing more and more resources, so everyone would want to move to a new world. In the beginning, only the richest would be able to do it, but with time, space travel would become cheaper. People would probably invest a lot of money to build a paradise on the second Earth. If this happened, we'd be visiting this world during our vacation to breathe fresh air and enjoy nature. In any case, the human population would grow. This means that sooner or later, the second Earth would become as loaded as the first one, and then people would start searching for a new home among the stars. By the way, if any life exists on a planet similar to ours, it's likely to look like octopuses. There's even a theory that octopuses came to Earth from some other world. Any animal has several evolutionary stages of development. For example, elephants and mammoths descended from one common ancestor 5 to 6 million years ago. Looking even further, almost all mammals evolved from one ancestor they shared with reptiles. Each species has been changing over millions of years. But not octopuses. They suddenly appeared on a family tree. From the point of view of evolution, squids would have to evolve into octopuses millions of years from now. But look, they're already here. Besides, octopuses are incredibly smart. Their genetic code is much more diverse than the human one. They may be visitors from another planet that is similar to ours. But of course, this is only a hypothesis. We're traveling through space at the speed of light. The route from Earth to the Sun at that speed will take only 8 minutes, but it would take us about 35 years to reach our destination, which is, by the way, still very fast. By comparison, a conventional rocket would take about 600,000 years to make the journey. And here we are. It's a star system suspiciously very similar to our own. And our scientists suspect that life could exist here, just like on Earth. A red dwarf, 30% the size and weight of the Sun, lies at the heart of this star system. But these are the planets orbiting the star that interest us most. The first of these is L9859b. Its size is somewhere between Earth and Mars, but it's very light. It's only half the mass of Venus. But life is impossible on this rocky planet. It's too close to the star, and it's so hot, you'd burn a cake if you tried baking it on its surface. It's about 100 degrees higher than the maximum of your oven. The planet makes a complete circle around its host star in just 2 days, compared to 365 for Earth. And it gets 22 times more energy than we get from the sun. So it's not only hot there, but there's a lot of dangerous radiation. The next planet is 2.8 million miles from its host star. That's 13 times closer than the distance from Mercury to the sun. And it makes a complete revolution around the star in 3.7 days. But what's interesting is that the planet is 30% bigger than the Earth and twice as heavy. So it belongs to the class of super-Earth planets. Such planets can be rich in water ice, methane, and hydrogen. These are some of the elements that are necessary for life's existence. Many scientists believe that it's on such planets that extraterrestrial civilizations can live. But because of the great weight of the planet, it has a strong gravitational force. So these civilizations may not be able to fly into space because it's harder for them to get out of the gravitational trap of a super-Earth planet. However, life isn't possible here because the planet is still too close to the host star. And just like in our solar system, the 2 nearest planets are too hot. But the third planet looks more promising. L9859d. It's almost twice as heavy as the Earth and 50% bigger. Scientists have calculated that about a third of its mass could be water. For comparison, the mass of all water on Earth is only 0.02%. The presence of water is the main condition for the emergence of life. But we can only guess where the water might be. It could be on the surface, but high temperatures can turn large oceans into giant clouds of steam. But water can also be contained in the groundwater below the surface. Well, we can't know that for sure yet. Let's move on to the next planet in the star system. This newly discovered planet is of the Super-Venus class, L9859e. It's a rocky planet 3 times the size of Earth. The Super-Venus class means that the planet is heavy enough to have an atmosphere, but the conditions there are more like a greenhouse. Different gases fill the atmosphere there. Star rays pass through them to the planet's surface, reflect off it, and rise upward. But the dense gases don't let them leave the atmosphere, so the planet gets hotter and hotter. This is the greenhouse effect that we try so hard to avoid on Earth. On top of that, the stellar wind carries water vapor and other elements from the upper layers of the atmosphere into outer space. Life cannot exist on such a planet, nor could it ever originate, just like on Earth's twin sister, Venus. So far, all the planets we've looked at are outside the habitable zone of the host star. That's the sweet spot at a perfect distance from the star. Not too close so that the planet isn't too hot and the water there doesn't evaporate instantly. And not too far away so that the planet doesn't look like a cold desert. And planets B, C, D, and E are too close to the host star. But there's another hypothetical planet F in this star system, located right in this sweet spot. This super-Earth candidate is 2.5 times heavier than our home planet. So we have hopes that it's a rocky world, just like the other planets in this star system. The weight of planet F is enough to have a dense atmosphere, and the temperature on its surface should be suitable for water to exist there in liquid form. The planet makes a complete circle around its host star in 23 days, which literally means it's New Year every 3 weeks. It isn't very likely, though, that there's a civilization there that celebrates it. Indeed, the very existence of this planet is very doubtful because we still have no direct evidence. All the other planets have been discovered by the transit method. That's when we point our telescopes directly at a star and watch its brightness change. When there's a slight drop in the star's brightness, that's when a planet has passed between us and the star, like this dot. We have a short period of time while the planet is in the background of the star to determine its size and speed. Sometimes we can observe such transits of Mercury and Venus on the solar disk. And there are at least 29 potentially habitable planets out there in distant space that can observe Earth in the same way. About 1,715 stars within a few hundred light years are perfectly located for it. Each star has planets around it, but only 29 of them are in the habitable zone. So there really could be life and an intelligent extraterrestrial civilization out there. If so, they could point their telescopes toward the sun and see a small dot pass across the solar disk. and they could have been making these observations for at least the last 5,000 years. So they could see how our civilization was born and how we evolved. Moreover, these planets are close enough to pick up our radio signals and even television broadcasts. But it works both ways. Radio signals travel through space at the speed of light. We mastered this technology about 100 years ago. So if there really is a civilization out there somewhere, we would pick up their signals too. But so far, it hasn't happened. So we have no proof of the existence of life on these planets. The discovery of a star system like L9859 is very important to us because we're always looking for life outside of our solar system. And super-Earth-class planets are even better suited for the origin of life than planet Earth itself. Such planets are sometimes called super-habitable. So some scientists think that Earth is a good place for life, but not the best. Super-habitable planets would have to be 30% larger than Earth and twice as heavy. This would create stronger gravity, which would make the atmosphere on the planet denser and with a higher concentration of oxygen. This in turn would raise the average temperature on the planet to a perfect 77 degrees Fahrenheit, so plants would thrive there. Also, stronger gravity makes the surface of the planet flatter, so there might be more oceans there than on Earth. This would make aquatic life much more diverse. The host star also plays a very important role. It should be smaller than the Sun. The bigger the star, the more of its fuel it burns. This means that the lifespan of such stars is much shorter. For example, the lifespan of the Sun is about 10 billion years, but a red dwarf can live up to 30 billion years. More time, more opportunity for the birth of life and evolution. So far, scientists have discovered 24 superabundant planets, but that still doesn't mean that there is life there for real. But some scientists believe that there are already at least 36 advanced civilizations in our galaxy, besides Earth. They've searched for similar worlds on the star map. First, we find stars that look like the Sun among about 100 billion stars throughout the galaxy. Now we choose from them those that are rich in iron. Such stars burn at the perfect temperature and help the planets around them gain an iron core and become Earth-like. Now let's pick relatively young stars from this pile, because when they get older, they expand and either absorb the planets around them or burn them up. One last thing, let's find planets in this pile that are in the habitable zone of the star. And voila! 36 worlds may be inhabited by some unknown civilization. But we won't know for sure until we get in touch with them.
Imagine you're looking up at the sky on a clear night, and you see all those beautiful stars twinkling up there. Well, one of them is Beetlejuice, a celebrity among stars. If you want to catch a glimpse of it, look up at the Orion constellation. It low-key looks like an archer holding a bow, and you can spot Beetlejuice as the reddish-orange dot on their shoulder. It's one of the brightest stars in the sky, so it's hard to miss. Beetlejuice is not your ordinary star. First of all, it's gigantic, up to 1,000 times the size of our Sun. Can you imagine that? It's so enormous that if we could somehow replace our Sun with Beetlejuice, it would engulf all the inner planets, including Earth. And here's another fun fact. When we look at Beetlejuice, we're actually looking back in time.
Yep, you heard it right.
Beetlejuice is about 600 light years away from us, so the light we see today actually left the star 600 years ago.
It has quite a history. This star has been shining brightly for millions of years. Long, long ago, even before smartphones and telescopes, ancient Sumerians were the first to spot Beetlejuice in the sky, and it's been a diva this entire time. For example, in 1866, Betelgeuse became one of the brightest stars in the night sky. It was so dazzling that people could see it even during the day. Astronomers all around the world went bananas documenting this extraordinary event. Since then, Betelgeuse has been playing hide-and-seek with us. It all started when Betelgeuse started to dim back in 2019. Since then, it likes to dim and brighten sporadically. But these changes in brightness tell us about something important. As we mentioned, Betelgeuse was always a bit of a troublemaker. It's been living a fast and furious life. Because of that, it has been burning its fuel at an incredibly fast rate. The changes in the star's brightness are clues that Beetlejuice is approaching the end of its life cycle. The drama intensified when the Hubble Space Telescope snapped jaw-dropping images of Beetlejuice, like it was getting ready to blow its top. All this made scientists think that the star is close to retiring in a dramatic way. It's about to go supernova. So picture a star partying hard, powered by the fusion of hydrogen atoms. It's like the star's own energy drink, but just like any party, the fuel starts to run out. That's when things get interesting. As the star guzzles up its hydrogen fuel, it slowly begins to run on empty. It can't sustain itself anymore. So now, it's time for the grand finale. This finale is called supernova. The star collapses in on itself like a deflating balloon. The pressure and temperature inside skyrocket to mind-boggling levels, and this celestial tantrum triggers a colossal bang. So you can see why observing Beetlejuice is like having a front-row seat to the spectacular drama. But here's the big question. When will this happen? Well, the answer is not as simple as setting a timer. You see, stars have their own schedules, and Beetlejuice is no different. It could be tomorrow, or it could be thousands of years from now. Scientists have come up with only a rough estimate. They believe that Beetlejuice will go supernova within the next 100,000 years. Quite a spread, huh? Sure, that sounds like forever to us, tiny humans. But in the vastness of the universe, it's just a blink of an eye. But there's a chance, just a tiny chance, that Beetlejuice could surprise us all and go supernova much sooner. Considering its dips in brightness, we might be in for a show within the next few hundred years. We'll just have to wait and see. Now, if Beetlejuice does go kaboom, what will happen? Well, get ready for a show like no other, folks. When a star collapses under its own weight, it unleashes a cosmic firework of epic proportions. The star releases a crazy amount of energy in the form of light and heat. Beetlejuice's supernova is going to be extra special. It's like the superstar of supernovas. It will shine so brightly that it might even outshine the other stars in the sky. Picture that, Beetlejuice stealing the spotlight. The show could be so bright that you won't need a telescope to catch a glimpse. Nope, you'll be able to see it with a naked eye. It might even be visible during the day, making the sky look like it's hosting the coolest rave ever. After that, the supernova will keep us entertained for weeks. It will be like having a second moon in the sky, shining as bright as the full thing. Imagine that, 2 moons dancing together in the night. After several weeks of lighting up the night sky, Betelgeuse's supernova will slowly fade away, but it would leave behind a souvenir, an ethereal remnant. It's like a fading memory of the star's epic performance. This remnant, too, would slowly fade away over the course of several months. But it's not just about the light show. The boom will send out powerful shockwaves, and we might actually feel them right here on Earth. It's like the universe giving us a gentle tap on the shoulder, saying, hey, look at this amazing spectacle. How dangerous will it be for us? Well, we know that Betelgeuse's supernova would send dust and gas shooting into the atmosphere. It's like a big space sneeze. And this sneeze could cause a decrease in global temperatures. We're talking serious climate impact here. It could even lead to a mini ice age. But these are just assumptions. We don't know for sure if the consequences will really be that serious. But, of course, we want to be prepared for this event just in case. That's why scientists are studying Betelgeuse closely. But, in addition to serious scientific research, astronomers also have a blast of celestial comedy. Jokes are flying left and right. Someone has even created a Beetlejuice status account, which you can check yourself. So, as you can see, the star is keeping us on our toes. Astronomers keep observing it, and they need our help too. They want us to keep an eye on Betelgeuse and report any changes we see. How do you do that? First off, channel your inner astronomer and observe Betelgeuse. Take a peek at the star and note down what you see. Is it twinkling, shining, or feeling a bit dim? Jot it all down. Then be a superstar yourself and report your observations to the astronomers. Your observations will help them track Betelgeuse's journey towards its big supernova moment. You can also join in on some citizen science projects. They're super fun and easy, trust me. One cool project you can jump into is the Beetlejuice Brightness Monitor. By participating, you help scientists keep tabs on how bright Beetlejuice is shining. Your contribution can make a real difference. So join the monitoring team. You'll be part of something amazing, and who knows, your observations might even help predict when Beetlejuice will show off its supernova magic. By doing that, we can assist them in monitoring this superstar and learn more about the fascinating world of stars. But that's how we can help scientists to predict this event. Now, how can you personally prepare for it? First things first, you'll need the right gear to catch all the supernova action. A trusty telescope is like your front row ticket to the starry show. It'll bring you up close and personal with Beetlejuice's performance. And remember, you'll need special eyewear to shield your eyes from the intense burst of light. Safety first. And of course, prepare in case it decides to mess with our climate. Stock up on essentials, like warm clothes and supplies, just in case we experience a mini ice age. But let's just hope it won't happen. So keep your eyes on the night sky, my friends. Beetlejuice may not be ready to blow up just yet, but when it does, it will be a sight to behold. Until then, let's enjoy the twinkling stars. And remember, there's always something extraordinary happening in the vastness of space.
Last summer, astronomers noticed something off, and it was, wait, that's not supposed to happen, off. They spotted a weird mix of signals in their data. After double-checking, triple-checking, and probably staring at the screen in silence for a while, they realized it was something they'd never seen before. They may have just caught the first ever super kilonova. You probably heard of supernovae, those big dramatic explosions marking the end of a star's life. It happens like this. A massive star runs out of fuel, its core collapses, and it blows itself apart. Sometimes a white dwarf star steals too much material from a nearby companion using its super powerful gravity. That stolen gas, mostly hydrogen, spins around the white dwarf in a disk and then slowly falls onto its surface, eventually triggering a massive thermonuclear blast. By the way, since we've mentioned it, a white dwarf is the scorching hot ultra-dense core that remains after a small or medium-sized star, like our Sun, exhausts its nuclear fuel and blows off its outer layers to form a planetary nebula. Then, over billions of years, it slowly cools and becomes a theoretical black dwarf. It's roughly the size of Earth but packs around the Sun's mass, which makes it incredibly dense. Black dwarfs are powered only by leftover heat, not ongoing fusion. Either way, the birth of a supernova is loud and bright. These explosions often leave behind a neutron star, which is so dense that a single teaspoon of it would weigh about 1 billion tons. Basically, less star and more cosmic anvil. But then there's this rarer kind of VIP event, the kilonova. Astronomers have only ever seen one of those. Back in 2017, one event confirmed what scientists had predicted for decades. 2 neutron stars slammed into each other and shook space-time with gravitational waves. Such collisions don't just look cool, they create heavy elements like gold and platinum. Kinda like a cosmic factory. There's a chance that the gold in your phone or on your finger was forged in a violent neutron star crash billions of years ago. Kilonovae have a signature look. The explosion produces so many heavy metals that they block blue light, leaving behind a deep red glow. It's subtle and incredibly hard to catch. Now, here's where things get interesting. What astronomers spotted in 2025 didn't really fit into the supernova box, but it didn't look like a regular kilonova either. It was too powerful and too strange. Neither did it behave the way either event should on its own. That's why some scientists believe they might have spotted something new, a super kilonova. We're talking about a collision or chain reaction so extreme that it goes beyond anything we've observed before. Right now, it's too early to draw conclusions. Astronomers are arguing politely running more simulations and waiting to see if the universe decides to do it again. Because in the universe, twice is often the proof. But how could this super kilonova occur? Scientists suggest quite a wild sequence of events. Picture this: a massive star collapses in a supernova, but instead of leaving behind one neutron star, it produces two. Almost immediately, those two ultra-dense remnants begin spiraling toward each other. Within moments, they collide and merge, setting off a kilonova on top of the original explosion. In other words, it could be not just one cosmic blast, but a chain reaction. Two of the most extreme events in the universe happening nearly back to back. The mystery itself started on August 18, 2025, when the LIGO and Virgo gravitational wave detectors picked up a signal from 1.3 billion light-years away. The event immediately caught attention. The ripples in space-time looked exactly like what astronomers would expect from two neutron stars crashing into each other. But there was a plot twist. The International LIGO Virgo CAGRA team quickly alerted astronomers worldwide. The data suggested a neutron-star merger, but at least one of the objects seemed unusually small. Together, the pair weighed just 0.87 times the mass of the Sun. But neutron stars aren't supposed to be that light. According to everything we know, they should weigh at least 1.2 solar masses. At the same time, the analysis showed a 99% chance that one of the neutron stars fell below that limit. That shouldn't happen under normal conditions. So either the models were missing something, or this object formed in a completely different way. For example, it could be some kind of exotic birth during the collapse of a rapidly spinning, neutron-rich star. So, just a few hours after the alert, the Zwicky Transient Facility at Palomar Observatory spotted something curious. There was a fast-fading red glow coming from the same patch of sky. At first, it seemed that this discovery could solve the puzzle. For the first 3 days, the object behaved exactly like a kilonova. It glowed deep red, which is a sign of freshly forged heavy elements like gold and platinum. Everything matched: the timing, the color, and the gravitational waves. Astronomers thought they were witnessing the second confirmed kilonova ever seen. And that's where things got weird. On day 4, instead of fading away like a kilonova should, the object started getting brighter and bluer. That's like a major red flag in astronomy. Follow-up observations from the Keck Observatory in Hawaii revealed signatures of hydrogen and helium in the light. And those chemical fingerprints do not belong to kilonovae. They belong to supernovae. More specifically, a Type 2b stripped envelope supernova. This kind of explosion happens when a massive star loses most, but not all, of its hydrogen before blowing itself apart. It often happens because a nearby companion star siphons material away. At that point, many astronomers wrote the event off as a normal supernova that just accidentally happened near the gravitational wave signal. After all, regular supernovae don't usually produce detectable gravitational waves, but the timing and the early kilonova-like behavior, plus the strange mass measurements, didn't fit into that explanation. The event started to look like something far stranger. Now, most researchers still admit there's a chance all of this was just bad cosmic timing. Statistically speaking, they can't fully rule out that the neutron-star merger and the explosion just happened to occur near each other by coincidence. Still, the overlap in both time and location looked strange, and they couldn't ignore it. What if both signals came from the same catastrophic event? It would be an extreme scenario involving a rapidly spinning massive star. This star wouldn't collapse into a single dense core. Instead, its breakneck spin would cause the core to split in two, forming a pair of tiny underweight neutron stars. These newborn neutron stars wouldn't last long. Almost right after birth, they would spiral toward each other and collide. That crash would send out gravitational waves and create heavy elements, just like a normal kilonova. But all of this would happen inside a much larger supernova explosion. In other words, it would be a hybrid. One cosmic disaster stacked on top of another. Interestingly, the term superkilonova wasn't actually invented for this discovery. Originally, it described a theoretical event where a massive, fast-spinning star collapses straight into a black hole, surrounded by a huge disk of material. This material is capable of producing giant amounts of heavy elements, possibly several times the mass of the Sun in gold and platinum. The new study suggests using superkilonova to describe a supernova that briefly creates and destroys a pair of neutron stars before anyone notices what really happened. The team is careful not to oversell the idea. After all, the event happened far away. Moreover, the signals overlap in complicated ways, and untangling them perfectly isn't possible with current data. So, coincidence is still on the table. But if superkilonovae turn out to be real, they would help us solve several mysteries at once. For example, they offer a way to form low-mass neutron stars and help explain how the universe's heaviest elements might be created. Future observatories could help us figure out this phenomenon. Upcoming missions like NASA's Nancy Grace Roman Space Telescope and the UVEX satellite will watch the sky, increasing the chances of catching more of these blended explosions. If astronomers start detecting more mergers involving unusually small neutron stars, the case will finally be solved. Until then, the idea of a supernova and a kilonova happening together remains one of the most intriguing what-ifs in modern astronomy.
Now, history teaches us that the supercontinent existed a long time ago, around 300 to 273 million years back. At that time, all the continents on Earth were buddies and hanging out together. They formed an amazing crew called Pangea, or Pangea if you're feeling fancy. The name comes from a Greek word which means all the Earth. Pangea also had a massive water neighbor called Panthalassa. So our entire world was a huge piece of land surrounded by a huge piece of ocean. The megacontinent looked like a giant sea, stretching between the tippy top and bottom of our planet. But as stories go, things change. About 200 million years ago, in the early Jurassic epoch, like dinosaur times, Pangea decided to throw a breakaway party. Forget about the old ideas of continents just drifting around like big icebergs. It split up into smaller chunks, forming the continents we know today. Oh, and it created the Atlantic and Indian Oceans as a bonus. Pangea's tale was first told by a German weather expert named Alfred Wegener in 1912. But how did he learn about something that happened so long ago? Imagine the Earth's core as a big, cozy fireplace, giving off heat. This heat creates special swirling currents in the Earth's outer shell. We can think of it as the Earth's crust, which looks like a big puzzle with many puzzle pieces. The hot currents make these puzzle pieces, called crustal plates, move around. Sometimes they push apart, sometimes they crash into each other, and sometimes they slide past one another. It's like a fantastic dance party that goes on beneath our feet. One day, Wegener looked at the shapes of the continents and thought that, hey, those coastlines of South America and Africa kind of fit together. And they really did. So he imagined that way back, all of the continents hung out together as one big landmass. But he couldn't just go and say that without any proof. So how do we know Pangea really was a thing? Well, there are some clues that brought us to this amazing discovery. One clue is like when you put a puzzle together and the pieces fit just right. Take a look at the shapes of today's continents. You'll notice that they could fit together almost like a perfect match. Obviously, their shapes changed over time. It happened millions of years ago, and since then, the shores of continents have been washed by waters for years. But even so, we can still see how well they fit together. Another clue comes from checking out fossils. We know that ancient animals left a lot of fossils behind. That's how we learn their history and what species there were. But when scientists compared fossils found on different continents, they found something interesting. These fossils look similar. Surprisingly, they belong to the same groups of animals, even though they were far apart. It's not like these animals could swim across the ocean on their 4 paws. And it's unlikely that this particular type of animal originated in 2 places at the same time. And finally, the mountains. Imagine exploring underwater and finding huge mountains in the oceans. These underwater ranges and deep trenches are like scars from when Earth's tectonic plates moved around. They serve as another proof that the continents are part of something bigger. When you look at these things together, you get a pretty clear picture. The Earth's continents were once huddled together in the supercontinent. They've since gone their separate ways, but the memories of their grand adventure are still written in the shapes of coastlines, the rocks they left behind, and many more. But it's obvious to us now. At the time of Wegener's discovery, there were different ideas flying around. Some folks thought that the continents sank down to make the oceans, but Wegener had a different take. He thought that the continents are always on the move. He even came up with a fancy phrase, continental drift, to explain it. Later, he was joined by another scientist named Alexander du Toit. He added a little twist to the story, suggesting there were 2 original continents, Laurasia in the north and Gondwana in the south. But the real party didn't start until the 1960s, when scientists figure out the secret ingredient in this recipe, plate tectonics. And finally, this theory explained everything Wegener and du Toit talked about. Wegener's theory was proven correct after 50 years. As time passed, we learned more and more about our planet. We found out that the Earth used to have multiple supercontinents. Before Pangea, there was a megacontinent called Rodinia around 1 billion years ago. And later on, Pannotia joined the scene about 600 million years ago. What's interesting is that the continental drift story is far from over. Our continents are always on the move. Africa is giving Europe a friendly bump, and Australia is playing a game of bumper cars with Southeast Asia. You know what's on the horizon? Another supercontinent. So, how will this next supercontinent come together? Well, there are 4 major possibilities: Novo Pangea, Pangea Ultima, Orica, and Amasia. These might sound like superhero names, but they're actually ways the puzzle pieces could fit. Let's look at them all. First, Novo Pangea. You know how there's the Atlantic Ocean on one side and the Pacific Ocean on the other? Well, if these oceans keep doing what they're doing now, the Atlantic will keep opening up while the Pacific squeezes in. If that happens, the Americas, North and South America, will give each other a big high five. And Antarctica, that icy land way down south, will join the fun too. It'll be drifting northward. Next, Pangea Ultima. In the future, the Atlantic Ocean might get tired of being so wide. It might decide to slow down and shrink a bit. The Americas and the northward drifting Antarctica will probably crash into Africa and Europe. And just like that, a brand new supercontinent forms. There are these spots where the ocean floor is sliding underneath the land. It's like a secret underwater passage. These spots are called subduction zones. So, if these secret tunnels will be spreading and spreading all along the east coast of the Americas. The Americas, Europe, and Africa might come together again, and they'd form a supercontinent. This supercontinent would be surrounded by the Pacific Ocean. The next possible supercontinent is Orica. In this scenario, the Pacific and Atlantic Oceans might decide to take a nap and close up. But don't worry, because when one door closes, another opens. In this case, a whole new ocean would pop up to replace them. Imagine a big crack in the ground cutting through Asia, like a zipper opening up. This crack is called the Pan-Asian Rift, and it would become a brand new ocean. With this new ocean comes a new supercontinent, Orica. Australia is currently drifting northwards, like it's trying to find a nice spot at the center of our planet. East Asia and the Americas might join in from both sides. After that, Europe and Africa might link up with the Americas, and boom, Orica. And finally, Amasia. It might form if some of the tectonic plates go north. They can take continents like Africa and Australia along for the ride. They'll be hanging out around the North Pole. All the continents except Antarctica might come together. And even though they might gather around the North Pole, they won't close off the oceans. The Atlantic and Pacific Oceans would still be open for business. How this grand reunion happens depends on the Earth's tectonic movements. So far, we believe that Novo Pangea is the most likely scenario. It also depends on what exactly happened to Pangea after it broke apart. And when the new supercontinent appears, what's going to happen with the weather? How will the ocean behave? And what about the animals and plants? These questions all light up our minds. Who knows? Maybe someday our descendants will look at the world map and see this incredible journey come full circle. So keep asking curious questions and stay tuned for the next 100 million years. Now really, an object weighing billions of times the mass of our Sun must be easy to find, right? Wrong. Unfortunately, it might not be that simple, like in the case with a missing black hole. But let's travel to the galaxy cluster Abell 2261, hosting a supermassive black hole at its center. Or at least, that's where it's supposed to be. The main problem is this giant space phenomenon is nowhere to be found. Now, supermassive black holes are mega monsters, churning slowly at the center of their home galaxies. They gather tremendous clouds of gas and dust around them, which makes them swell up to sizes the human mind can't begin to imagine. If a supermassive black hole, like the one that dwells at the center of our home Milky Way galaxy, moved even a little bit closer to our solar system, we'd be doomed. The distance between this huge thing and Earth could be several dozens of light years, and still it would wreak havoc on our planet. Earth, along with other things making up the solar system, would be tugged into the black hole's orbit and doomed to spin around it for eternity or longer. Hey, who knows, right? So, it's good that such black holes stay away from us at the moment. So, let's see what happened to that runaway supermassive black hole from that gigantic cluster of galaxies around 2.7 billion years away from our planet. Scientists have been looking for it with the help of NASA's Chandra X-ray Observatory and Hubble Space Telescope. But so far, no result. The main problem with finding a black hole is that it's, black. And space is, you guessed it, black too. So there's no contrast whatsoever that could help astronomers spot the hole. But scientists haven't given up yet. After all, they have a lot of other technologies to find black holes, small and big, in the vastness of space. Some of these methods involve watching the stars orbiting black holes. Sometimes it's a faint gravitational wave signal, which is produced when two black holes collide. But the most reliable technique is watching dust and gas falling to their doom. The thing is, black holes are space objects with insane gravity. So regions of space surrounding them are usually a bit chaotic, gas and dust getting pulled into the bottomless abyss, compressing and heating up. In the process, it releases a flood of X-ray radiation. So, astronomers look for extremely bright X-ray sources in the universe. Chances are those are the last gasps of giant clumps of material before they disappear into a black hole. Then, why can't scientists find such X-ray signatures left by the black hole in Abell 2261? One of the most mysterious things about its disappearance is that radio telescopes have spotted some signs of massive plumes of superheated material launched at one point within the last 50 million years. These plumes were most likely caused by a large black hole, which is nowhere to be found these days. So, at the moment, we can only play a guessing game. Maybe two medium-sized black holes collided, pushing the newly merged giant out of the center of the galaxy. The observations of the stars in that galaxy have shown a clump of dense material a few thousand light-years away from the galaxy's core. Maybe it's the runaway black hole, but disappointingly, no X-ray signals are coming from that clump. Or the hole might still be there in its rightful place, but it's, slumbering. If it doesn't get a fresh supply of gas and dust, it has nothing to feed on. As a result, it can't release a flood of X-rays. But again, the answer, "Do not disturb, the black hole is sleeping now," isn't very satisfying. Why isn't it getting its space food? What happened 50 million years ago? What is that clump of material speeding away from the galaxy center? So many questions, and no answers so far. At least we know what black holes look like. Well, kinda. It's actually the shadow of a black hole's event horizon, visible against the glowing superheated material falling inside the hole. The first ever mugshot of a black hole appeared in 2019, but the data for its creation was collected in 2017. It took an international team consisting of more than 200 astronomers 2 years to assemble the image. We can admire this amazing space phenomenon thanks to a vast global network of telescopes called the Event Horizon Telescope Collaboration, or simply EHT. Why such a name? The thing is that the event horizon is a point of no return on the outskirts of a black hole. When something, for example, matter, radiation, or light, reaches this boundary, there is no way for it to escape the black hole's clutches. Anyway, to capture that very first image of a black hole, scientists created a virtual telescope that turned out as big as our planet by combining the power of 8 powerful radio telescopes. But it wasn't an easy feat. The researchers had to simultaneously point the telescopes in a meticulously planned order with the help of precise atomic clocks set on each telescope. Plus, to keep the chances of rain and bad weather to a minimum, they even constructed the telescopes in super dry regions, such as the Atacama Desert in Chile and the South Pole. On each observation day, the telescope gathers roughly 350 terabytes of data. That's 10 times the amount of data collected every day at the Large Hadron Collider. But let's speak more about black holes themselves. There are stellar black holes, smaller but even more dangerous than their supermassive peers. They appear when stars that have run out of their star food fall into themselves. If a star used to be big enough, it keeps compressing and compressing some more, and voila! A baby stellar black hole is born. But even if I call such a hole a small one, it's still 5 to several tens of times heavier than the Sun. Unlike their massive siblings, hypothetical mini black holes could be really tiny, not bigger than an atom. Even so, just one minuscule thing would have the mass of 1,000 SUVs. One theory claims tons of micro black holes could have been created right after the Big Bang and the beginning of the universe. Some scientists even go as far as to say that a couple mini black holes pass through our planet every day. There is a supermassive black hole smack dab in the middle of our galaxy, the Milky Way. Its name is Sagittarius A star, and it's 4.3 million times as heavy as the Sun. And nope, we aren't going to be pulled into this hole. It's more than 26,000 light-years from Earth, too far to have any influence on our planet. By the way, recently, astronomers have discovered that this supermassive black hole might be leaking. If it's true, it probably means that Sagittarius A star isn't a sleeping giant, as previously thought. It might still be active. And the leakage recorded by scientists may be the hole hiccuping while swallowing clouds of gas. Maybe we should burp this baby? If you ever find yourself near a black hole, get ready that time will significantly slow down. It may work for you if you aren't eager to grow older. Just don't let yourself be tugged beyond the point of no return. Another danger of hanging around a black hole is that it might start behaving like a massive galactic volcano. From time to time, black holes flare up, but instead of spewing lava, they produce enormous amounts of energy, and it makes gaping holes in the surrounding material and gas. A short time ago, scientists discovered one of the largest craters in the universe. Radio and X-ray telescopes detected a supermassive black hole that threw a temper tantrum many years ago. It happened in a galaxy cluster about 390 million light-years away from Earth. The crater left behind, which was actually a hole punched in the cluster's hot gas, could fit 15 Milky Way galaxies. Okay, mind blown, I'm out of here. Castles were cold places in times past. The stone seemed to radiate the winter chill. This is one practical reason why tapestries were hung upon castle walls, to help keep the cold out and the warmth in. But you just can't hang any old thing on castle walls. It should be beautiful, heroic, with a heavy wow factor. The ancient Greeks hung tapestries on the walls of their castle of the sky, glorious tapestries woven of stars. All 48 constellations of the Northern Hemisphere were designed and named by the Greeks. The story of Andromeda is one such tapestry, woven of 7 constellations spread across the entire autumn sky. The story contains detailed astronomical observations preserved as highlights in the sky tapestry. It begins with the constellation Cassiopeia, queen of the oldest realm in Africa, Ethiopia. When the constellation Cassiopeia is on the horizon, it looks like a staircase going up to the Milky Way. Step pyramids around the world are often thought to have been inspired by the constellation Cassiopeia. In any case, Cassiopeia is a beautiful constellation, indicating that Queen Cassiopeia was also a beautiful woman. She was good-looking, but equally vain, which sets off all the dramatic action. Cassiopeia can be found in the night sky opposite Ursa Major from the North Star. Like Ursa Major, Cassiopeia circles the North Star and is a circumpolar constellation. A supernova was observed in Cassiopeia around 1680 Earth time, Cassiopeia A having occurred about 11,000 years earlier. The Chandra X-ray satellite recently recorded an extraordinary photograph of this supernova remnant showing the elements sulfur, calcium, silicon, and iron amid the expanding cloud's high-intensity X-rays. Cassiopeia's husband is also a circumpolar constellation, a minor, dim one named Cepheus. He had his own kingdom. A merger of empires by way of marriage is something common throughout history. Cepheus was a king of Phoenicia. There were many kings of Phoenicia back in the days when Phoenicia was just a collection of city-states along the western shore of the Mediterranean Sea. Cepheus can be found in the area between Cassiopeia and the North Star. The constellation of Cepheus is important to astronomers. It's where Henrietta Swan-Leavitt discovered variable stars that pulsed at regular intervals. The rate of pulsation of the star indicates the true brightness of the star and enables a sure measurement of the distance to the star. The discovery of Cepheid variable stars was a major breakthrough for early 20th century astronomy. Cepheus and Cassiopeia had a daughter, Andromeda, also a noted beauty, about whom all the fuss is. It seems that one day Cassiopeia was boasting about the beauty of her and her daughter Andromeda. "We are more beautiful than any other women in the whole wide world." Well, such pretension can be forgiven for a queen. But then Cassiopeia went further and stepped beyond all natural bounds. In fact, "We are more beautiful than any of the Nereids." Well, the Nereids were Greek mythological sea nymphs, daughters of the ocean. Noted for their beauty and kindness to sailors, the Nereids, all 50 of them, took offense at being dissed by a mere mortal woman. Cassiopeia had to be punished for exceeding the bounds of the civil order. By her excessive vanity, Cassiopeia transgressed beyond the bounds of nature, for which an unnatural punishment was inflicted upon the entire kingdom of Ethiopia. A monster from the bottom of the ocean, the constellation Cetus, began to devastate the coastal villages of Ethiopia as well as Ethiopia's fishing ships. Fittingly, Cetus is a constellation of the southern celestial hemisphere. The fourth largest by area of all the constellations, Cetus swims in a dark part of the sky called the ocean, with only its head rising above the celestial equator. This part of the sky contains several water-themed constellations: Pisces, the fishes, Aquarius, the water-bearer, and Eridanus, the river. Over 50 exoplanets have been discovered in Cetus. You can bet the James Webb Space Telescope will have a field day analyzing the spectra of these planets' atmospheres, looking for signs of life. Meanwhile, Queen Cassiopeia and King Cepheus must do something about the monster devastating the shores of Ethiopia. They consult an oracle and make another trespass beyond the realm of reason and nature. "Tell us, oracle, what can we do to stop the monster from ravaging our kingdom?" This monster is not a normal affliction of nature. An offense was committed against the higher realms, and this is the punishment. The monster cannot be stopped by any normal means. Only a human sacrifice of the noblest being may placate the beast. One error compounds another. The noblest person in the kingdom, of course, is Princess Andromeda. According to the command of her father and the consent, or perhaps a suggestion of her mother, Andromeda is chained to a rock offshore. She is the human sacrifice that her parents hope will save the kingdom. Wow. Da-da-da-da! Here comes the Greek hero to save the day, stop the human sacrifice, and turn Cetus to stone. Perseus. Now, where is Perseus coming from? According to legend, the Hebrides. Perseus went to the Hebrides in pursuit of the Gorgon Medusa. The geological scope of this tapestry is incredible, from the Hebrides to the Red Sea. The Hebrides are an archipelago of mostly rocky islands off the western coast of Scotland. It was impossible to sail any further. The Hebrides were the absolute end of the world. Perseus didn't have to sail to the Hebrides. However, he flew on a pair of winged sandals. Hey, way to go, Perseus! Now, Medusa was one of the all-time baddies. One look at Medusa was so terrifying it would petrify you, literally turn you to stone. Perseus was in great danger. So, what did our hero do? Instead of looking at Medusa, Perseus used the scientific principle of reflection. He slew Medusa by seeing her reflected in his polished shield. In our sky tapestry, Perseus is portrayed holding up the severed head of Medusa. In the night sky, one eye in Medusa's head opens and closes and opens again. Arabic astronomers named the star Algol, the ghoul. Algol is an eclipsing double star. One star is bright, the other one, not that much. As the dimmer star orbits the bright star, it passes in front of the bright star, eclipsing it, and the eye closes. Since the dim star takes 2 days, 20 hours, and 49 minutes to orbit the bright star, the eye in Medusa's head opens every day and a half or so. The constellation of Perseus is immediately below Cassiopeia, and skywatchers quickly look to see if Algol is eclipsed, if Medusa's eye is open or closed. Perseus flew back from the Hebrides, accompanied by Pegasus, the winged horse. The central part of Pegasus is the Great Square, made up of 4 stars. As Earth goes around the Sun, the Great Square is right in the center of the night sky in autumn. In the summer triangle of Vega, Deneb, and Altair are in the middle of the night sky. In spring, it's Leo the lion, and in winter, it's Orion the hunter. These are the walls of the castle in the sky, and all have marvelous tapestries adorning them. The constellation of Andromeda shares a star named Alpheratz with Pegasus. It's one of the corners of the Great Square, so it appears Andromeda may be riding on Pegasus. Her crown, remember she is a princess, is floating nearby. M31, the Andromeda Galaxy. To see M31, cross the corners of the Great Square from the lowest star to the uppermost star, and then go a little further to see the Andromeda Galaxy. Be sure to peek at it from the corner of your eyes. It's called averted vision. The corners of your eyes are more sensitive to light, so you'll be able to see the huge spiral galaxy 2.5 million light-years away as a smudge of light 1.5 times wider than the full moon. Now, Perseus doesn't go in for human sacrifice, so he stops it and saves Andromeda by exposing Cetus to Medusa's gaze. And here we encounter the second eclipsing variable in our sky tapestry, Mira, the heart star of Cetus, the sea monster. Mira, from which we get the English word mirror, so fitting in a story about vain beauty, is an eclipsing double star. The dim star orbiting the bright star is a white dwarf, not bright enough to see with the unaided eye. The effect is that Cetus's heart shuts off. Mira is eclipsed and disappears. This cycle repeats itself every 332 days. Our fabulous star tapestry has the only 2 eclipsing binary stars visible to unaided eyes, the nearest spiral galaxy, and a hero that doesn't like human sacrifice and uses the scientific principle of reflection to thwart mythological monsters. Wow, I would hang that in my castle too. Just saying. The Earth. Frozen and alone, exiled into deep space. Jupiter, the only remaining planet orbiting the Sun. No, it's not a premise for a disaster movie. It's one of many real scenarios scientists explored in their latest simulations. This time, the threat isn't the sun swelling or a giant asteroid knocking planets into it like a cosmic bowling ball. It's something quieter and possibly already on its way. A recent study examined the potential consequences of a passing star coming too close. One such flyby could send planets crashing, flinging them into space, or mess with their orbits just enough to cause climate changes. But what are passing stars, and how likely is that to occur? Passing stars are normal stars, like our Sun, that move around the Milky Way. Since everything in space is always moving, sometimes stars pass near each other. Usually it's not a big deal. But if a star gets really close, its gravity can tug on planets like Neptune. That tiny tug can slowly change how the planets move, like a ripple spreading through the whole system. Scientists study these close encounters because, even though they don't happen often, they can have big effects over millions of years. They help us understand shifts in planetary orbits and how they may have shaped Earth's past. In fact, one theory suggests that a flyby 56 million years ago is what caused great climate change when Earth's temperature rose by up to 14 degrees Fahrenheit in just a few 100,000 years. That huge temperature jump changed life on Earth, leading to the evolution of some species while causing others to disappear. Even though it's impossible to prove whether there was a flyby a long time ago, we do know that events like this could mess with Earth's orbit in the long run. That's in the past, but what about the future? So far, we know that the solar system will have a close encounter with another star called Gliese 710 in about 1.3 million years. Gliese is moving towards us and is projected to pass within 10,000 astronomical units of the Sun. It won't come close enough to throw planets off, but it could still send icy comets from the Oort cloud our way, like a bored kid tossing a snowball without looking. One might hit something, but probably won't. However, in a recent study, scientists wanted to explore a more extreme scenario. What if a star passed even closer, say just 100 astronomical units from the Sun? That's about 100 times the distance from Earth to the Sun. From our point of view, it's almost unimaginably far, but in space, it's practically brushing shoulders. They ran thousands of long-term simulations covering up to 5 billion years of our solar system's future, and it turns out it doesn't take much. Just one close encounter can be enough to disturb the outer planets, like Neptune, and set off a slow-motion chain reaction that ripples inward. Over time, that gentle nudge can throw the whole system into chaos, a true cosmic butterfly effect. The good news is that even in this worst-case scenario, in 95% of simulations, the passage is nothing to worry about, and all the planets remain in place. However, in the remaining 5%, well, it's one disaster after another. The most frequent casualty in these simulations was Mercury. In nearly half of all unstable scenarios, Mercury ends up on a doomed path straight into the Sun. It's the smallest planet and the closest to our star, so it's especially susceptible to gravitational nudges, whether from the gas giants or from a disturbance rippling inward from a stellar flyby. When Mercury spirals into the Sun, you might think it's game over for the rest of the planets, but that's not always the case. Sometimes the system absorbs the loss and restabilizes, like an orchestra that keeps playing even after one violinist falls off the stage. Oops. Funny enough, Mercury already has a chaotic orbit, the most stretched and tilted of all major planets, and some studies already consider its fall into the Sun in the distant future inevitable. Now, Venus has a slightly better chance in these chaotic scenarios. It doesn't get ejected or swallowed by the Sun as often as Mercury, but it's far from being safe. Most of the time, the instability happens after Mercury goes rogue and disrupts Venus's orbit, nudging it into a slow-motion crash course with Earth or Mars. Even without the interference from field stars, long-term simulations show a tiny but real chance that Venus could eventually collide with Earth just from the way Jupiter affects Mercury. A Venus-Earth collision would result in both planets being completely destroyed. Oh well. A similar fate awaits Mars. According to simulations, in about 0.3% of cases, it either gets flung out of the solar system or collides with another planet. Mars is smaller and lighter than Earth, with weaker gravity, which makes it easier to knock it off track. What's interesting is that even in some cases where Mars is lost, Earth often manages to stay in place. Jupiter happens to be the heavyweight champion of the solar system, the proud owner of its own cloudy belts. Thanks to its massive size and strong gravity, it acts like an anchor, keeping everything else in check. There are 392 scenarios out of 12,000 simulations where all but one planet vanished, with Jupiter being the last one standing. Its stabilizing influence helps prevent smaller planets from going off course, and in some cases, it even helps the system recover after a disruption. Saturn, while less massive, seems to be Jupiter's loyal partner. But models show that when Saturn shifts its orbit abruptly, it can send gravitational ripples, known as secular resonances, straight into the inner solar system, nudging the orbits of planets like Earth and Mars. Finally, the most vulnerable ones are Uranus and Neptune. Sitting at the edge of the solar system, they're the easiest to knock loose, and in many simulations, they get ejected entirely. That loss sends gravitational ripples inward, disturbing the rest of the planets over millions of years. Even a tiny shift by 0.1% in Neptune's orbital distance can throw the whole solar system out of sync. The balance of gravitational forces would shift, forcing Jupiter and Saturn to readjust, which would push the disturbance toward the inner planets, destabilizing everything. Which brings us to the big question: what about Earth? While most simulated models leave Earth untouched, about 0.2% of the simulations end with Earth either colliding with another planet, Venus, or being thrown into the Sun. Out of 12,000 simulations, in 23 of those, Earth ends up as the only one still orbiting. But that's only if we don't include the Moon in calculations. With the Moon included, Earth becomes harder to predict. Our satellite could crash into Earth, get ripped away by a passing star, or destabilize our orbit over millions of years. Once again, this is a worst-case scenario, and while the odds are really, really small, it's not impossible. So, with that in mind, let's entertain the idea and see what would happen to Earth if it were to end up exiled from the solar system. Earth would become what scientists call a rogue planet, drifting through interstellar space with no sun to anchor it. The surface would quickly freeze, with temperatures dropping to hundreds of degrees below zero. But surprisingly, life wouldn't vanish completely. Earth's core would stay hot for billions of years, powered by radioactive decay and leftover heat from its formation. That heat could keep underground pockets warm. Scientists believe that this is the case with icy moons like Europa or Enceladus. Life might cling on in different caves or buried oceans. It wouldn't be a thriving world, but it wouldn't be completely empty either, at least for a while. Just cold, quiet, and alone. A ghost of a once lively world. And somewhere out there, maybe another civilization will look up, spot a faint blue dot drifting by, and curiously start running simulations of what might happen if this blue planet were to get really close, say just 100 AU from their sun.
Astronomers detected something strange happening in the darkness of space. They picked up a series of bizarre, unexplained signals coming from distant stars in the Ursa Major constellation. And literally no one can explain their origin. Is it some unknown natural phenomenon or something far more mysterious, more artificial? Let's explore this latest space discovery, the science behind these signals from space, and what scientists believe might be sending them. So, scientists picked up two identical bursts of energy coming from deep space. They weren't random and they weren't background noise. They seemed to be precise and even kind of purposeful. The signals came from the constellation Ursa Major. It lies about 100 light-years away from our planet. The star emitting those signals is called HD 89389. It's a little bigger and brighter than our Sun, but nothing too unusual. That is, until 2023. That's when NASA scientist Richard Stanton noticed something he'd never seen before. The star suddenly flashed, getting bright, then dim, then bright again, and it happened in just a few seconds. There were two identical pulses, exactly 4.4 seconds apart. According to Stanton, the star's behavior was beyond strange. The changes in brightness were far too powerful to be dismissed as random noise or the result of turbulence in Earth's atmosphere. A star over 1 million miles wide doesn't simply fade in and out like that. For a star to just blink out like that in 1/10 of a second is not the kind of thing science can explain easily. But it got even more curious. And the more scientists looked, the stranger it got. Apparently, this wasn't just a flicker, it was deliberate. It looked like something made that light change. But what could it be? It was a truly deep space mystery. So for the next 2 months, Stanton worked a lot. 1,500 hours of total observation time, checking every possible explanation. He compared the data to lightning strikes, airplane reflections, meteors, and even software malfunctions. And every single time, the result was the same. Nothing matched. That's when the research team had to admit what no one expected. Apparently, they couldn't rule out the possibility that those pulses might be artificial. The thing is, after checking every possible explanation, Stanton realized that their space telescope discovery wasn't something anyone had seen before. It couldn't be explained as static, it wasn't lightning, and it definitely wasn't a passenger plane flying by. But it reminded him of something. You see, back in 2019, astronomers detected another strange double pulse. This one was coming from a hot gas giant called Dibitium, about 50 light-years away from Earth. At first, experts laughed it off and blamed it on birds flying through the telescope's field of view. But the new signal didn't seem like one of those simple mix-ups. So, Stanton kept digging. He looked at everything and concluded that a shockwave in Earth's atmosphere could explain the signals. But that idea didn't quite fit. For all 3 pulses to sync up that perfectly, the timing would have had to be almost impossible. The researchers also looked into other possibilities. Maybe the light was bent by some far-off object in our solar system. Maybe a satellite or asteroid partially blocked it. Or maybe it was caused by refraction or even gravitational waves. But none of those theories really made sense either. Some details were clearly missing for astrophysicists to explain how a star could blink that fast and that cleanly. For now, Stanton believes the only way forward is to study all 3 known events more closely and see which explanations still hold up. You're probably asking yourself, how was this astronomy discovery even made? It started more than 60 years ago. That's when scientists officially kicked off the search for life beyond Earth. They called it the Search for Extraterrestrial Intelligence, or SETI. The pioneer of this undertaking was something called Project Ozma. It was led by astronomer Frank Drake, the same guy who came up with the famous Drake equation. This equation is a way for scientists to make an educated guess about how many worlds in our galaxy might have intelligent life that can send out signals we could detect. The idea is simple. You start with how many stars are born in our galaxy. Then you figure out how many of those stars have planets and how many of those planets could support life. Then you gotta figure out how many of those worlds might actually have living things and how many of those might develop intelligent beings. And finally, you try to calculate how many of those might build technology that could let them communicate with other civilizations, like ours. Now, the equation isn't really meant to give a clear number. It's more like a big thought experiment that helps scientists consider all those different pieces needed for life to exist and be noticed in the universe. Anyway, back in 1960, Drake and his team pointed a giant 82-foot radio dish at two nearby stars, Epsilon Eridani and Tau Ceti, and listened for anything unusual. Between April and July of that year, the observatory in West Virginia stayed tuned in, waiting for a signal from the stars. Unfortunately, nothing came through. But the project became the starting point of everything that came after. Since then, scientists have carried out dozens of similar searches using all kinds of wavelengths and technologies to find signs of intelligent life. These days, we call them technosignatures. And while no one's found solid proof yet, there have been a few moments where even experts couldn't rule out the possibility that something, or someone, might be out there. That's where Dr. Richard Stanton comes in and makes the shocking space discovery. Stanton is a NASA scientist who worked on some of the most iconic missions like Voyager and Grace. The latter was a project by NASA and the German Space Agency, where two satellites flew around Earth together, side by side. By watching how the distance between them changed, scientists could see how Earth's gravity shifted in different places. That helped them learn about things like melting ice, ocean movement, underground water, and even climate change. But after retiring, Stanton took on a personal project, searching for intelligent life from his own Shea Meadow Observatory in Big Bear, California. Using a custom-built telescope and a photometer he designed himself, Stanton spent years scanning more than 1,300 sun-like stars, not for radio signals from space, but for flashes of light. Unlike traditional SETI studies that focus on radio waves, Stanton's approach, called optical SETI, looks for laser-like pulses, sharp, quick bursts of light that could be used for communication across the stars. This idea actually goes back to the early 1960s, when two scientists suggested that advanced civilizations might use incredibly powerful nanosecond laser pulses to send visible signals that could outshine their own stars. For this study, Stanton didn't scan huge portions of the sky. Instead, he focused on one star at a time. He was staring at it for an hour straight and recording its light at incredibly tiny intervals, just 100 microseconds apart. That's fast enough to catch flashes less than a blink of an eye. Then he analyzed the data, searching for any strange repeating patterns and unexplained signals, and eventually, his efforts paid off, and he made the very space discovery we talked about. A sun-like star, about 100 light-years away in the constellation Ursa Major, sent two fast, identical pulses of light. So far, these signals remain unexplained. No one knows for sure what caused those perfect twin pulses. We can't even figure out how far away the source really was. Was something passing in front of the star? Or was the light itself being changed by something we don't understand yet? What we do know is that something strange is happening out there in Ursa Major. Maybe it's a new kind of cosmic event. Or maybe it's something else entirely. And one day, we'll crack this deep space mystery.
Now, let's think for a moment. What if, instead of building spaceships to move across the stars, a super-advanced civilization decided to turn their entire star system into a spaceship? That means a whole sun, the planets, all the asteroids, zooming through the galaxy together. That's what one philosopher, Clement Vidal, suggested in his recent space theory. There could be countless reasons why these extraterrestrials might decide to explore space. Maybe the star nearby is about to go supernova, blowing up and destroying everything nearby, including their home system. Or maybe they're searching for new resources somewhere in outer space or trying to spread life. But our galaxy has a minor problem. It's incredibly huge. So even if they move with the speed of light, getting from one star to another would take a gazillion years. Ooh. However, if we could just move our entire solar system, that would be convenient. We wouldn't have to change a thing or look for another star system and planet. How, though? Well, they'd use their own star as an engine, literally a stellar engine. All they'd need to do is push their star and everything orbiting it in a specific direction. You must cause the star to spit out material unevenly, creating a kind of thrust. It's like our rocket propulsion, but applied to entire stars. When more material ejects on one side of the star than the other, it acts like a rocket, slowly nudging the entire system along. Over time, they could steer it to wherever they want. Now, this isn't just some goofy idea, well, maybe, but many scientists have proposed different models for how a stellar engine could work, and how we humans could use it. The most famous one is called the Shikhatov thruster. Here, the idea is to use a giant reflective mirror to push a star gently in one direction by reflecting its sunlight. Other designs propose ejecting mass from the star itself. Of course, that'd be insanely hard for humans to pull off, but a super advanced civilization might just do it. And it might not be as hard as it sounds. There are already stars in the galaxy that move at incredible speeds. They're called hypervelocity stars. These stars are so fast they can escape the galaxy itself. Their story begins in the heart of the Milky Way. At the center of our galaxy lies a monster, a supermassive black hole with gravity so intense nothing can return from it. We even took a shot of it a while ago. Remember this one? It's called Sagittarius A star. We start with a pair of binary stars. They are similar in mass and orbit each other. Sometimes they stray too close to a black hole. When this happens, one star can get captured by the black hole, its fate sealed, while the other gets the wildest roller coaster ride of its life. It's like a crazy slingshot. It's hurled outward with unimaginable force. These exiled stars gain incredible speeds, like over 1,000,000 miles per hour, and become hypervelocity stars. Now, this doesn't happen that often. Maybe one hypervelocity star is flung from the galactic center every 100,000 years. And with over 100 billion stars in our Milky Way, finding them is worse than needles in a haystack. But even so, we managed to find about 1,000 such exiles in our galaxy. But anyway, could these superfast travelers be extraterrestrial starships? Maybe it's some wild move other civilizations decided to pull off, getting slingshot by a black hole so they could travel wherever they want at wild speeds. Now, most hypervelocity stars studied so far are single stars. But what about binary systems themselves? This binary system we mentioned would make this whole process of turning a star into a spaceship much easier. Another civilization could focus their efforts on one star in the pair. The interaction between the two stars could be used to fine-tune direction and spin, like a built-in steering wheel. It would also help use energy more efficiently. Let's try implementing this. Take a neutron star. This is what's left behind after a huge star reaches its end. Its tiny, incredibly dense version. These little neutron stars are often paired with the small and normal ones. Neutron stars have some insane gravity. This could help them provide the energy needed to push the whole system. So, if an extraterrestrial civilization decided to build a machine like this, they'd probably do that near a binary system like this. But would our extraterrestrial friends settle for basic binary systems? Actually, they could go even further, for a wilder, more efficient option – Black Widow pulsars. Ooh. This is the most dramatic type of a binary system. A neutron star spins with unbelievable speed and doesn't just hang out with its companion star, but slowly devours it. These two create such a thrilling gravitational dance, it's both destructive and beautiful. As the neutron star spins, it just keeps flinging torrents of high-energy particles right into space, and all of them clash with the fragile remnants of its poor little partner. Can you imagine that this energy could be harvested? All these options – hypervelocity stars, binary systems, and spider pulsars – would be great for this stellar engine project. A civilization that had this type of engine could gradually explore and colonize the galaxy, all while having its own energy source and planets with them. But how do we know whether these starships actually exist? Astronomers look for something called technosignatures. These are little clues and hints, something that looks unusual for normal celestial bodies. For example, things like weird motion in binary systems, or stars that eject material in weird, unnatural ways. They could all mean that there's some technology being used there. We haven't any evidence of that so far, but there are candidates. There are 2 Black Widow pulsars that look strange. Clement Vidal, the author of the paper, says that we should look at those systems closely, just in case. And even if it turns out that this idea is incorrect, we can still use it as an inspiration for ourselves. If extraterrestrial civilizations won't do this before us, we might just pioneer that technology. And speaking of technosignatures, besides these starships, NASA is also looking for signs of megastructures in space. Maybe other civilizations don't treat their stars as some sort of chariot horses, but simply use them as a giant energy source. Life needs energy to survive, whether it's microbes, animals, or smart human-like civilizations. As life evolves, its energy demands skyrocket. Now, we started with fire, then moved to coal and oil, and now we're exploring solar power. One day, we might start harvesting the power of our sun directly. Maybe advanced extraterrestrial creatures are already doing this. On Earth, a physicist, Freeman Dyson, proposed the idea of a Dyson sphere, a huge structure around a star that can harvest its energy, like one enormous solar panel, but right around the sun. Sounds crazy to us, but we might find it somewhere out there. Once again, astronomers are checking technosignatures to spot those. For example, they've analyzed data from over 5 million stars, trying to find weird signals, flickering, or anything that can't be explained by dust or similar stuff. If we're talking about a Dyson sphere, then eating a star's energy would make it radiate a lot of infrared heat. That means we'd notice a telltale glow. Eventually, they narrowed it down to 368 possible suspects. They checked those, and only 7 stars remained. These stars show strange light patterns that we really can't explain yet. These stars are mostly small, faint red dwarfs. One of them is especially famous, called Tabby Star. It blinks and dims in weird random ways, dropping in light by 22% from time to time. Astronomers aren't sure whether it's some broken moon flying around it, dust, or a Dyson sphere. In any case, they'll keep looking for these techno-clues.